All right, it is now recording. All right, we're going to get started. I've started recording. Looks like we have most of our remote participants tuned in. Excellent. And let me minimize that. All right. Just like this morning, remote folks, if you have any questions, just speak up. We can hear you. And let's go. Let me just switch screens here. Hopefully this works. Yay, there we go. Okay, let's get started. Missing a few people, looks like, but that's all right. They're late. So, this morning we just talked about basics. A lot of the basics of how statistics work, what we're really looking for. But now we're going to talk about factor analysis. There are two different stages of the SEM process. One is dealing with your measurement model. So this is sort of your measurement model. So the remote folks can see. Here we go. Laser pointer. This is your measurement model, where you're trying to figure out which items, these are like survey questions, which items belong with which latent factors. So this factor here, curiosity or creativity, these don't exist without these items. We didn't measure creativity. We measured 1, 2, 3, 4, 5 items that capture this idea of creativity somehow. And so we use a measurement model to determine if these items really do move together and capture this idea of creativity. That's the measurement model. And then there's the structural model, which hopefully will show up here. Here we go. The structural model, which is the relationships between those constructs. So tomorrow we're going to talk a lot about the structural model. Nope, tomorrow's CFA, more measurement model. Saturday we're going to hit the structural model. Today and tomorrow we're going to talk about the measurement model, both exploratorily and confirmatorily, if that's a word. I think it is. I'll pretend. Okay. I have a bunch of slides in here that say FYI at the top right corner. That means I'm probably not going to go over them. They're just for your reference. I'm gonna go over them differently. Like this. I like visuals. This is new. Okay, so we talked about variables moving, right? Variables have variance. They move. And do they move together? If they do, maybe they're part of the same construct. So when you look at this, which ones are moving together?
A, D, and E.
A, D, and E, we think are moving together. Are you sure A, D, and E are moving together? Are you positive?
Oh, it depends when.
When one's so assume the y-axis here is values low to high, 1 through 5.
That's clever.
So which ones are moving together?
Depends when you look at it.
Yeah, absolutely.
So that doesn't count. We're going to iterate several times. We're going to be looking at it always.
A and E and C.
A and E. Oh, look at them. Okay, let's watch them for a couple times. A and E. Looking pretty good. C and F. C and F look pretty consistent.
That is very clever.
What about D and B? Who are they with? Oh, you know,
Well, they follow each other.
A and E. This is tricky. Okay,
Oh, now
just to make it a little bit more helpful, or easier. Okay, now watch.
Oh, they're negatively correlated.
Negatively correlated.
That's good enough.
We have a hard time when we have a lot of items to feel around with. It's kind of hard as humans to crunch it, right? The exploratory factor analysis, it takes all your items, usually not just 6, usually more like 40 to 100. Can you imagine doing this with 40 to 100? This would be really difficult. And it says, oh, here are the general corresponding movements among your variables. So it sort of color codes it for us, finds groupings for us, which is very helpful. If we go back to this slide here, it finds the measurement model. It finds that, turns out, CR1, 2, 5, 4, and 3, they all sort of move together, just so you know. And so you can sort of factor those into a single factor. That's what the factor analysis is doing. You like the visual? That's new. Yeah, all right. Just seeing if it worked. All right. Moving forward.
Do that in PowerPoint?
Yeah.
How long did that take?
5 minutes?
No.
I'm a super user. I can just watch it all day, you know.
But then, the green and the red go against each other in some way too.
Right. Well, but they're not perfectly correlated. Yeah. So the tightest correlations are within color. Some of them are inversely correlated, but they are systematically moving together. Anyway, so SPSS will find these movements for you. We have this correlation table right here. SPSS takes this correlation table. Really, it's taking the covariance table, but this works just fine. And you see we have all these variables on the left. They're also on the top. And these are the relationships, the correlations between all the variables. These are their joint movements, right? And so SPSS takes this and converts it into a pattern matrix, which is essentially those groupings. It says, oh, these ones move together. Oh, these ones don't move with those ones, but they do move together. And so it finds all those different groupings for us, all those corresponding movements. And it does this over many iterations, trying to figure out which ones are moving at the same, systematically with each other. Does that make sense? Yeah? Doesn't make any questions about that? Because that's what we're going to do the rest of the afternoon is play with the EFA. Okay, cool. Yeah.
Commonalities, where that come from?
Communalities, we'll get to that, but the quick answer is that's the extent to which one item corresponds with all other items in that analysis. The extent to which it correlates, not corresponds, correlates.
Is the threshold still 0.5 or?
0.4 is okay. We'll get to that for sure. Now, what I showed you back in the pattern matrix, that's a statistical look at correlations. But you can't just look at it statistically. You have to look at it conceptually. Why should these items move together? There's got to be some theoretical reason, some underlying theme or concept or trait. So I figured we could do that with these. What are the underlying traits or themes we could use to factor? How do these guys move together or not? They're all men. One factor. Done. Right? We have two factors. Barack and the rest. We did ethnicity or skin color, I suppose. Beards. Huh?
Beards?
Yep, beards. And mustaches. So facial hair. We could say there are multiple factors. Glasses. Yeah. Yep, bald. Indicted. Nice, nice. Corrupt or not, that's one factor, right? Yeah, two terms, multiple terms or one term. Democrat, Republican, or other. Died in office. There we go. Yeah, have a few of those. Cool. We can do all sorts of things associated with a growth period or with a decline period. All sorts of things. So when they move together statistically, we observe this. We need to then go back and see, well, is there a corresponding similar movement conceptually? Should they be moving together? If not, we might need to trim things out a bit.
That all feeds back to the way the data were built by the respondents, how they looked at it, and whether or not
How they interpreted things.
how they interpreted
Yeah.
what we wanted them to group themselves by.
Yeah, we have an a priori measurement theory, right? We think that these 5 items belong to curiosity, these 5 items belong to usefulness, but we need to see how the respondents interpreted things. That's why we do this exploratory factor analysis. When do you have to do an EFA? I say pretty much always, because you always have different data. Unless you're using secondary data that has already had an EFA run on it. Secondary data is like someone else's data, and they've already run the EFA. But if you're collecting your own data, do an EFA. Most of the problems I address online, I get lots and lots of questions online every day. You remote folks, you contribute a lot of them. And a lot of the problems we run into is they never ran the EFA. They just jump straight to CFA or just jump straight to a structural model without even looking at the measurement model. And that runs you into all sorts of problems, which I will explain.
How come Mitt Romney's not on this? Well, he's not.
Are you sure? Wait, I know he's there somewhere. Wait for it. I think he's there. No, maybe not. Maybe? I know he's there somewhere.
I think it's only on the other view.
No.
not
He's got to be there.
No, I saw him, like, he's.
Yeah.
There he is.
Oh, there he is. All right.
I think you do. Just kidding.
Has nothing to do with where we are. All right. Okay. This is FYI, but it's worth explaining. EFA is for several different things. For exploring patterns in the data, seeing the correlative movements. For reducing your data. So sometimes you collect on 100 different questions, right? And you only need 80 of them or 60 of them. Oftentimes when I do these analyses with students, we end up cutting a whole third of the survey out because some items we just don't need. We have 10 items to measure one thing and we only really need like 4 of them. The ideal in the literature, the ideal is 4 items per latent construct. Any less than that and you start getting a little bit unstable. Any more than that and it's just overkill. There's a lot of overlapping variance explained.
Do you have a particular citation?
No, I can't remember off the top of my head. I'm sorry. But it's 4
Wait, so 4 items per construct?
per latent construct, yeah. That's the ideal. But you can definitely do it with more or less. 2 is getting really unstable.
But not 1.
1 means it's not latent. It's observed.
What if it's an established skill?
If it's an established scale, you better stick with what they made. Otherwise, you risk offending them, and they'll probably be one of your reviewers. So yeah, if it's an established scale, you just keep the whole thing intact, unless it's a terrible scale. I've had terrible established scales, and I've cut them down, and I've listed my reasoning for reducing the scale.
Some scales have pretty distinct parts.
Right. Oh, like a multi-dimensional scale. Let's say we're collecting on performance, and there's like this part of performance, and that part of performance, and that part.
Where they could be cut, I think.
Yes. I was just working with somebody on this. Yeah, George. We were just working on this, and what'd you end up doing?
I haven't really done much, but I went out to look for responsibility and accountability constructs.
So just smaller scales.
I didn't really find one, but I found a responsibility construct that was used in a health service research.
Uh-huh.
And I've done, I've changed the words in a little bit. And I've sent it to Tim for comment.
Oh, good.
To see what he thinks.
So you started with like a 60-item scale for a single construct, right?
Yep.
That's ridiculous, because you imagine if you had like 3 of those, you only have 3 constructs and you have 180 items.
Yeah, it's a 5-dimensional construct.
Yeah.
And 50 questions.
Yeah, just ridiculous.
That's what I think.
So you have 2 options. You can reduce the scale by cutting out the dimensionality. So there are no longer 5 dimensions. You're just sort of capturing what is responsibility, what is accountability, something like that. Or you can write your own scale. Usually not looked on as favorably as reducing the scale or finding a shorter scale. Yeah. Okay.
Question on
Yeah.
that. That's a really interesting, and it's a little bit off topic today, but what does that mean from dimensionality? Sometimes those dimensions are really important.
Right.
Do you split them out to your own constructs, into little sub-dimensions?
This often depends on what you're trying to accomplish with your study. Are you trying to build off of someone else's study who's used this multidimensional scale?
Yes.
So if you're doing that, you have to keep that scale because you're extending that study. But if you're just looking for a construct that captures this trait, go get another one. Go get one that's going to be easier. Yeah.
Good answer.
So, James, the way you explain this and the way it seems that the EFA kind of works out of the box is really tailored toward reflective constructs.
Yes.
So
Yes.
Yeah, so how do you deal with that?
We'll talk about formative at the end.
Okay.
But yeah, very insightful. This is built for reflective. One more thought on reducing scales. The social desirability bias scale started out as like a 50-item or maybe 28-item or something like that scale. Over the years, people have refined it and refined it. It's down to 5 items And that's the scale you use, is a 5-item scale for social desirability bias. So it can be done. You just have to justify it. And the last thing is the reason, or the application of factor analysis is to confirm a hypothesis, or confirm your factor structure. We go into it thinking these 5 items belong to this, these 5 items capture this, and this helps you confirm that theory. But why EFA? Why not just jump to the structural model? This is the model we want to test. This is our structural model. This isn't the one we're going to test. This is a structural model. We think that playfulness will increase joy, which increases performance when using software. And efficacy, self-efficacy, increases the perceived usefulness of the software, which increases performance. This is our theory, right? This is what we think. This is what we want to test. But when we collect data, these are the points, these are the variables. This is not a perfect analogy, but these dots are the variables and how they lay out. The distance between them is their tightness of movement together, the tightness of correlation. So really what we're testing is this. If we don't do an EFA, we're testing if this blue, this was playfulness, affects this yellow, which was joy, affects this performance, which is this. I mean, it's kind of a mess. It's more muddy than we'd like. So if we're trying to say that red was self-efficacy, if we're saying that red predicts green was usefulness, what are we really predicting here? They're overlapping. It's hard to tell. If you don't do an EFA and sort of trim things down and tighten things up, you would be testing this, and you know what you'd find? Nothing. Nothing at all. If items don't move tightly together, well then how can you say that that movement predicts some other movement? If you don't have a systematic tight movement here, if it's inconsistent here, how can it consistently predict something else which is also inconsistent? And so you won't have significant effects. And that's why you do the EFA. So again, we want to test for this. We end up with this. And what we do is from here, we try to consolidate. We want to find the tightly moving items and sort of trim off the fat. And so you end up with this. Turns out efficacy just didn't roll together. We didn't collect it right. Maybe our items were ambiguously worded. People didn't understand them. Usefulness was tight. We got rid of the stuff on the edges. But we ended up with something like this too. This is part of an EFA very often. You never intended to capture whatever the gray thing is, but you did. There was this group of items that just moved really well together. What are they? Yeah.
Sometimes you get maybe parts of it stay with you and then the rest of it just disappears.
Yeah, that happens too. With this one, we have a little bit of everything. So what is this little bit of everything? Statistically, it's a factor. We should go then look at the questions themselves and find out if there's an underlying theme. And then it might become a new factor. If not, we just cut it out because it's just a statistical anomaly. Yeah.
If it's a new factor, does that become a new finding then?
Yeah, that'd be an interesting finding. So in our EFA, we found a new factor with these items and it captures this construct. Yeah.
So that's actually what you're looking for in any kind of research, is that something unique.
Something unexpected. Yeah. I rarely see this reported though. Usually people would just cut it out because it's not what they expected. So they're like, it doesn't match their theory. But really, it's an interesting finding.
Dr. James?
Yes.
Why do we do the EFA and SPSS? Why don't we do it in AMOS immediately?
In AMOS, you can do what's called a confirmatory factor analysis. AMOS doesn't allow you to do an exploratory factor analysis. The exploratory factor analysis lets you run a factor analysis without any constraining theory. We don't go into it saying these items belong to this construct, these items belong to this other construct. Whereas in AMOS, we say these 5 items belong to this latent construct. And so we're sort of constraining it. The EFA lets us do it completely unconstrained.
When we do the EFA and SPSS, and then you come up with the final factors or the final items that, representing each of the factors. And then when you take it to AMOS, you don't really find a fit, like a model fit.
Yeah, you find poor
Then
fit.
Like you find that the model is not really that fit. Then you have, while you're doing the confirmatory, maybe you remove some of the items, or I found it sometimes that you need to change the whole item. I don't know if that's correct or not, but do you change after the EFA, if you went to the confirmatory, you change the items? Or you just stick with whatever you already found? in
No,
the EFA?
you certainly can. Once you get to the CFA, you can actually continue to trim and move. The EFA was just exploratory. We use the CFA to confirm, but while we're confirming the factor structure, we can still trim out some items if we can't obtain good validities or model fit. Yeah, and we'll do
Even
that.
though sometimes when you do the EFA, you will find that item was cross-loading with another item.
Right.
But when you go to the confirmatory, if you put that item, you find that your model is fit. So sometimes I feel the EFA is confusing.
The EFA is definitely harder to reach a good conclusion than the CFA. But if you don't reach a good conclusion in the EFA, it's hard to reach a good conclusion in the CFA.
Isn't it just as simple as
You're welcome.
being concerned about the number of factors? Isn't that the main thing you're really interested in?
Well, you're interested in how many factors are there and which items belong to those factors.
Right.
Yeah, exactly. And here we are. Last thought on why. This is on reduction again. If we don't do an EFA, let's say we just start doing regressions from items to items, I mean, you're doing a pretty complex model. These are individual items. Whereas if you do the EFA and you find factors, you can just do, this lump to this lump, this factor to this factor analysis. And then I think we're going to do it pretty soon here. How many cases? We've talked about this a little bit. For every item, every individual variable in your data set, the rule really is 10 times. I use 5 times as a minimum. Some people say if you have 100 cases, 100 rows in your data, that's enough. Honestly, I have never found that rule to be very useful. 200 might be okay. 5 times the number of variables is the one I tend to stick with. How many variables do you need for an EFA? More than 3. Otherwise, if you only have 2, you can't have 2 observed, or you can't have 2 latent factors. You can only have possibly 1. So you need at least 3 or I guess 4 for an EFA. If you try to do an EFA on a bunch, like 100 plus variables, it's going to take eternity and it might not converge, might not minimize. So you might have to split it up. I've often had to split up my EFA into parts and then combine it at the end after I've done some trimming. Normality of data, not required for an EFA. Not required. But it does run you into issues. If you have like highly kurtote data, it doesn't move, and so you can't find its correlations with other items because there is no correlation. And can you pool data from 2 different samples? Yes, if you do a Levene's test or show that they have the same factor structure. Let's move on to it. Let's just do it and talk our way through it. There are a bunch more slides after this, which I'll come back to if we need to, just to double check we've done everything. But I'm actually going to open SPSS and do it. Escape, come on. There we go. Okay. Good, we are recording right now. Oh, good. Bootcamp day 1 morning is up on YouTube. Woohoo! Okay. Let's go to SPSS. All right. Let's run a factor analysis. Get that open. I'll give you a sec. Get that open, and we'll run a factor analysis.
You're still using the data from this morning?
Yeah, yep, exactly what we did this morning. So you go to Analyze, Dimension Reduction.
Is there something on the screen that you're supposed to show? Is there something up there you're supposed to show?
You didn't want to look at pictures of me and my daughters? Let's see. It's this stupid new system.
James?
That's a very young James. That was during my freshman year, I think.
Last year, wasn't it?
Yeah. I've aged a lot in the last year. 10 years.
EFA?
There we go. All right. Analyze. dimension reduction factor. Okay, what do we want to throw in there? We have 375, I think, cases, so we could do the whole thing at once. We have enough data to do the whole thing at once. So I'm going to throw in everything from atypical use 1 down to usefulness 7.
But not the control.
Not the controls. Yeah, ooh, good question. You only want to throw in your latent factors, right? You're trying to see a latent structure. So you wouldn't throw in things like age, education. Those would not factor into latent variables. So, you guys good?
Atypical use all the way down to 7.
Yeah, useful 7. Atypical use to useful 7.
So James, frequency of use and experience, those are considered latent.
Except there's only one item for them. So they're not latent.
So you need more than the other.
Yeah, it's latent if there are multiple items
Right.
to capture it. Yeah.
On one of the slides, like 2 slides ago, when you said you need at least 3 variables,
Mhm.
you meaning like 3 items?
Yeah, 3 items.
Construct?
Yeah, I should throw up my slide. I have a slide that shows all the different names for stuff in statistics. So you have items are also observed variables, there are a bunch of other names. I can't remember them. You have also latent constructs, variables. You call all of them variables because they vary. You have error, residuals. You have paths, betas, standardized regression weights, coefficients, effects, all for the same thing. We like to use lots of different terms for the exact same thing in SEM.
But what if a control variable is a latent factor?
Oh, then you could throw it in here, or if you have a few of them, throw it into a separate one. But you could do it in here. Yeah. Good question. Yeah, if you have a latent control, feel free to throw it in.
James, is there any reason to do dependent versus independent separately?
Ah.
Or if you know...
There are different schools of thought on this. So your dependent variable should be correlated with your independent variables, right? So if we throw it all into the same factor analysis, are we going to have weird cross-loading issues? The answer is hopefully not. So you do include it. Here's why. There's a word, tautological. It means you're measuring something with itself, predicting something with itself. If they can't factor out in a factor analysis, they're not different. And so you're not actually predicting X with Y, you're predicting Y with Y. And so you should, my experience is, you should throw your dependent variables into a factor analysis to show evidence that they are actually different, distinct variables.
Not moderators.
Moderators, if they're latent, you can throw them in there. Moderators technically shouldn't be theoretically correlated with your other variables anyway.
Control variables?
Control variables, if they're latent. Anything latent in your model, you can throw in an EFA. Anything latent. But
age is not latent.
age is one item, so not latent. Education, not latent. What about categorical variables? Things like, what if industry, but that's captured with one thing. So frequency of use is actually a continuous variable, so that's fine, but it's not latent. Experience, also not latent. It's just one thing.
Education is not latent.
If you had 2 dimensions of something, yeah, it could happen in here. It's still latent if it has 2 separate dimensions.
Education is not latent.
Education is not latent, so we don't throw it in. Anything latent and reflective, which we'll talk about.
It doesn't matter if they're on different scales.
No, we could have 1 to 7, 1 to 10, 1 to 5. There's actually research out there that shows anything 1 to 5 or 1 to 10 is fine. Once you get less than 1 to 5 and greater than 1 to 10, it starts doing some weird things. So my preference is always used a 1 to 5.
So if you did throw age in there, why doesn't it just come out as is?
It would be its own. It would, yeah, but it's not latent.
Affect anything, it'd just be its own factor, right?
Right, but it's not a latent factor.
Yeah.
So you would never throw it in anyway. Yeah, but you're right. It should just come out as its own thing. Okay, moving forward. Descriptives. I would like the reproduced matrix and the KMO. And we'll see why. That's in the descriptives area up here. Reproduced and KMO. For anyone, does anyone here, when they click on that, nothing happens? Good. Good. Continue. For extraction, I'm going to use maximum likelihood. The reason I do that is because that's what Amos uses by default. Also, it provides a model fit measure, which is nice. There are many different others you can use. They all have their different quirks. And I have a slide on all of these. But I'm going to use maximum likelihood. If you want a scree plot, you can include one. I never do because it's just replicating a table. And we have some options here. We can either extract a number of factors unconstrainedly, just let SPSS figure out how many we want or how many we should have, or we can say, yeah, we have 7. We have exactly 7, and that's how many I want. Don't extract any more or less. I'm going to let it flow freely for a sec. See what SPSS thinks. Continue. On rotation, again, there are different types of rotation. I'm going to use Promax for reasons stated in the slides. And continue. I'm not going to do anything under scores, but under options, I will suppress small coefficients under, let's say, 0.3 for now. What that does is it cleans up the matrix so it's not as messy.
You sort by size too.
You could sort by size. I think we should be fine sorting by size. That just puts the highest loadings at the top and then goes down to the lowest loadings for each factor. And continue. And if you wanted to do this for 2 separate groups, let's say I want to do it for gender, I throw that into the selection variable right here. I can say when gender equals male, run this. Or when gender equals female, run this. And you can see if we have the same factor structure. But I just want to do it for all the data. Hit OK, and it runs, and let's walk through it. How many of you have never run an EFA before? I just need to know how deep I need to go. Okay, several of you. Okay, we're going to go kind of deep. For some of you, this is review. You're allowed to take a nap or help me out if I say something stupid. Okay, the KMO and Bartlett's test. This is a measure of adequacy. Is this list of items here that we threw in, is this list of items adequately correlated, sufficient that we can actually run an effective EFA? If they're not correlated, if they don't move together, well then, imagine those boxes we were watching bounce up and down. If none of them had any systematic correlated movements, EFA would be useless. I mean, there are no groups. And so this is a measure of adequate correlation. We want it above 0.8-ish. We have 0.9, which is great. You can actually get down to 0.6 without getting into too much trouble.
Because you said before on descriptive, when you click significant levels, I can't click on it.
You can't click significant levels. Significant. One moment. On which?
Descriptive.
Descriptives.
I can.
KMO and reproduced.
No, and significant levels.
Significant. This one.
Yes.
I don't click that one, but you can if you want. Yeah. Okay. The sig here for the KMO should be significant. That means things are adequately correlated. I've only twice seen it not significant in my life. One time was when the guy ran his study when I told him not to, because he hadn't cleaned out his variables well enough, he hadn't pre-tested it well enough, and he went ahead and did it anyway. And sure enough, he got back garbage. So, told you so. And then another time, it was just, what was it? They had formative. We'll talk about formative versus reflective, but they had variables that weren't suited to a factor analysis. And so it wasn't going to work anyway.
And that significance refers to the Bartlett's.
Yes. Yeah. So they're adequately correlated is what that means. Yeah, MC?
What's the mailing number on the
0.6. There's a slide here. Let's see if you guys can see it. Yep, cool. Let me scroll down to here. The Kaiser-Meyer KMO. These are actually technical terms. This is from literature. No joke. From Kaiser and Rice, 1974. And so it's marvelous if it's in the 90s, meritorious, middling in the 70s, mediocre, and miserable in the 50s. I would not go below 0.6. In fact, if you have below 0.7, you probably have some issues. Probably a lot of kurtosis issues or ambiguity of questions issues.
So this reflects the entire group of variables.
Yeah, everything together, the KMO. Is there enough correlation to extract factors?
I always wondered why, if you could have a gross measure of individual factors.
It's just, yeah, altogether. It's like sum of squared error. I mean, it's for everything, but it's one measure. That's not what this is. I'm just saying it's sort of like
Did you
that.
say there's not enough correlation or there's not enough factors?
Correlation. So for this case, we do have enough correlation. There's plenty of correlation among the variables in order to extract factors. So this says there are latent factors. We can do it. The communalities table, if you look at the extraction column, we want things above 0.4, ideally above 0.3 if we have to. What this is how well does this one item correlate with everything else? If it's not correlating with anything, then it's not going to fit into a factor very well. So we look down here, let's see. We have really good values. 0.39 for playful 1, good enough. 0.39 is pretty close to that 0.4 threshold. Looking down, 0.377, that's probably fine. 0.303, that's getting pretty borderline right there. So what we'll find probably is decision quality 8 doesn't load well. So keep that one in mind, decision quality 8. Yeah.
Because I'm using my own data, I have a small, I haven't finished my data collection.
Okay.
I have 50, but I have
Oh.
a lot of latent variables.
Oh, so you'd have to run pieces at a time,
Okay.
or else it won't run,
Okay.
or run really unstably.
Because I got a low KMO, but all of my extraction values are actually pretty good.
Okay, yeah, so what you might do then is run half of the constructs and then the other half.
Okay, thank you.
Yeah, yeah.
When you're doing the winnowing process, if you see anything below a 3 on the commonality chart, before even looking at anything else, you just jump those questions.
No, so that's a good question. Is the KMO something that's going to lead us to action? No, it's going to just place a little red flag, and we'll keep that one in mind. So let's go ahead and look at the red flag here. We had decision quality 8. Let me jump straight down to the pattern matrix. Ignore everything for just a sec. Here's the pattern matrix. Decision quality 8, kind of a low loading, 0.509. So it just didn't load terrifically. Let me go back up. But that's what you do. You just flag it. If it had a 0.0 something, no, just flags it.
Is this because you're running a maximum likelihood? Because I ran it PCA and I run it.
PCA is very friendly
Okay.
and gives you higher values.
Okay.
Yeah, yeah.
So is PCA, I mean, I guess I'm still not 100% clear on the whys behind you might do maximum likelihood versus.
So I have, let me show you the slide on that. Do-do-do.
Yeah.
Here we go. I have a slide just for you. Okay.
PCA and then PAF. Yeah, that's what I was
Pourquoi?
trying to. PAF, yeah. These
Yep.
three. PAF versus.
When do you use which? This tells you exactly what they do, and hopefully you can infer why you'd use them then. I almost always use maximum likelihood, again, just because that's what Amos is going to use, and so I wanted to try to be consistent. Also because it produces that model fit measure. It produces a chi-square and a degrees of freedom when you use maximum likelihood. So I can see right off the bat if I'm going to hopefully have good fit. Whereas PAF and PCA don't. PCA is really friendly. It maximizes the correlations and potential factors. PAF, I believe, is the one that seeks the least number of factors possible to account for all the correlations. So this one's really strict, this one's really friendly, and this one's really nice. Yeah. And then I also have a slide on rotations if you want. 2 slides on rotations, FYI.
And the lowest factor loading is 0.4, and you said?
We'll get down to that. Yep, let's go ahead and move down. First, though, on the total variance explained table here.
Can
This,
I ask you a quick question?
of course.
I'm fairly comfortable with factor analysis, and it's a little different than I usually do, but my commonalities chart is not coming up. And it's giving me the warning about one or more greater than 1. I'm wondering where I've gone wrong, because I'm following your data set.
Oh, did you use maximum likelihood and pro-max rotation?
Yep.
Did you throw in age and education?
No. Did you guys throw an age?
No.
Okay, I just want to know where I fall.
One other thing, did you throw in the ID by accident?
No.
Okay, well, my guess is it's something, one of the items you threw in by accident. Maybe there's something in there, or if you accidentally didn't do Promax and maximum likelihood.
Okay, no big deal.
Okay.
The second set of items, is that the model?
I'm sorry, what?
The second set of items.
Comp latent?
Yeah.
That's comprehensive use. Yeah. Do you know?
Model?
It's what?
It's in the model.
Yes. That's all right. Okay. This total variance explained, this is how much, this is like the R square, sort of. This is the amount of variance explained by the factors we're extracting. We want to maximize this. 100 is great, but unachievable unless you stick all of them in. See, here's 100 if we have 43 factors, but that's one item per factor.
You didn't constrain that, right?
No, this is freely unconstrained. Yep. And so it extracted, 7. That's what we wanted. That's great when it happens like that. It rarely does, but that's great when it does. Maybe I should try a harder model next time. Okay. You want this number, this cumulative percent variance explained, to be above 60 if possible, above 50 at a minimum. This scree plot is identical to the table. It's just a visual representation of the table. Here's one eigenvalue here, and we should see 7 dots above the 1. I never use a scree plot. It's just visual. Skip the factor matrix and jump down to the goodness of fit. Okay, the goodness of fit test. I'm going to say a lot more about this tomorrow. But what this essentially says is, to what extent do the factors we extracted account for the major correlations in the data? Are we missing major correlations by extracting only this number of factors? Should we extract more or less? And what we want to see here is that the chi-square divided by the degrees of freedom is somewhere between 1 and 3. Maybe up to 5, but between 1 and 3 is nice. And we see that it is about 2, which is just right. So we have pretty decent fit. The number of factors we extracted is about right. If I were to force this out to 10 factors, we'd have a worse fit. This massive...
And that's explaining the variance, right?
No, that's explaining the model fit. That's explaining how well the factors account for the major correlations among the items. Yeah.
So just to
Yeah.
so the degrees of freedom you want over 3?
The degrees of freedom, they can be whatever, but more than 0 would be nice. But we want the chi-square divided by the degrees of freedom to be between 1 and 3. Yeah. And we're going to talk again a lot more about model fit tomorrow when we do confirmatory factor analysis. This big fat matrix, don't worry about it except this very small thing at the bottom here that says there are 34 or 3% non-redundant residuals. We just want it less than 5%. That harks back to the alpha of 0.05 or confidence level 95. We just want that to be minimized. 0 is optimal.
What is the theoretical logic of this value?
Minimizing error. Yeah, so the smaller the percent, the less error we have with those factors extracted. Yeah.
Sorry, would you mind? Sometimes there are numbers that are rules of thumb.
Did you get your computer working?
Linda is.
Magic. Yeah, she is. Okay, go ahead. Sorry.
It's running better than before.
Oh, good. Okay, go for it. What's your question?
So I'm happy. I'm a happy girl. So you get these rules of thumb. For example, in the specific case of you want less than 5% non-redundant residuals.
Yeah.
Say more about where the logic comes from in defining that number.
Yeah, again, that number, we're trying to minimize the error. This is an explanation of how much error we're observing with these factors. So if we were to include 10 factors, would we be minimizing less error, or would our error be less or more? And so this is hopefully minimizing error. And this is how much error we're observing. It's up to 3%.
How would you write that?
You wouldn't.
Okay.
It's just FYI. I mean, if you really wanted to, you'd have one line with a parenthesis that said we had 3% non-redundant residuals, indicating we had good fit for our factor structure.
I noticed when doing this that if you are the items, it automatically replaces
I'm sorry, somebody else is speaking remotely. Just a sec, remote. We have a local question. Just a sec.
So I'm curious, it seems to favor the fewer number of questions. So if a person's doing an EFA to be truly exploratory, to see what's coming out of questions, to see, okay, I'm looking at integrity, what are the different elements of integrity that are showing up to me? When you have like more than 5%, but you're having more questions and they're not cross-loading, okay to have that error?
So the question is, does the number of items included in the analysis affect this non-redundant residuals value? The answer is yes. It does. Also, your sample size does. And so the more variables you have, the more potential you have for error. But the more sample size you have, the more potential you have to minimize that error or to cover it up.
Okay. So if you're going to keep a large scale, then just increase your sample size.
If possible, yeah.
Okay, thanks.
Okay, somebody remote had a question. Go ahead.
Yeah. What happens if the error is greater than 5%? I'm using on there and I get 16%.
Yes, that's very normal. So we'll play with it is what we'll do. We'll try to minimize that by doing a few things. And what we'll do is we'll be looking at this pattern matrix down here to look for clues as to why this number is so high. In fact, I should throw in some bad stuff just to do some mitigation in a minute. I'll do that because this looks way too clean. Okay, there's a question here locally.
I did not get a goodness of fit table, did I not?
You didn't use maximum likelihood. Yeah. You might have scrolled down by accident while you were still active in that window. Yeah.
Is it possible to turn up the brightness?
Turn up the brightness? I don't know. It would be on the projector itself.
You turn down the lights.
Yeah, I could turn down the lights. Let me play with it for a minute. Is it hard? Is it just hard to
It's
see?
a little hard, but the first row I'm complaining.
Yeah.
Is that all right? Ish? Now that's a little dark. Is that okay for those taking notes? Okay.
How did you get the subscripts there that you actually give you the information about the
I'm sorry, I can't hear. I'm getting old.
So like the right above the pattern matrix, you have the subscripts that tell you the information about the residuals.
Yes.
Do you have to check something to get that? Because I don't have any of that. I have all either everything else. Freedom is not displayed.
Sorry, one more time. What are you missing?
So you have the goodness of fit table, right, and you have the table right
Yes.
below it.
Yes.
What did you check to get that box? Right
This
there?
big table?
Yeah.
Reproduced matrix in the descriptives area.
Descriptive.
Descriptives reproduced.
Okay.
Yeah.
Thank you.
Yes.
So way back up to the eigenvalues.
Yep.
Does an eigenvalue have an interpretation, and is one mean anything other than just a decision rule?
How to say this? The one is arbitrary, but has meaning. One is, the higher the eigenvalue, the more variance is explained by that factor. And so one is the sort of minimum threshold of how much additional variance is being explained. 2.55, I believe, is the threshold, which, I don't know if you're familiar with statistics, 2.55 is this sort of magic number for a critical ratio, like a t-value or a z-score, where 2.55 is significant at the 0.0, I think, 1 level. So that's where we get that number, and it's based on how much variance that factor can explain in that set of variables. I don't know if that makes sense, but that is what it is behind it. Were there any other questions before we move forward? Cool. All right. Goodness of fit. Pattern matrix. Here's what we really want to look for. The pattern matrix. Okay. We want this pattern matrix to be beautiful and clean, which it happens to be, which is no good, except these two items. Yes, we have problems. Excellent. Okay, good. Let's play with that. We want values in here to load well. Like above 0.5 would be nice, all the loadings. In fact, within a single factor, we want the loadings to average out to above 0.7. In order to be Convergent. There's this thing called convergent validity, which means how well do items move together. You think on that that graphic we had where you had all the dots all over the place, right? The tighter the dots, the stronger the loadings. The stronger the convergence or convergent validity. The further apart the dots, we don't have much convergence going on. So convergence is represented by these item loadings. And we see that decision quality loads on factor 1, and they all load together, which is great. But some of them load kind of low, like decision quality 6. That's kind of a low loading. Would I use that? Probably not. It's way below 0.5. I'd probably drop this right now, even before the CFA. But let's wait on it. Usefulness, gorgeous. Everything's above 0.5, looks fantastic. Joy, also just beautiful. Playful, beautiful-ish. Atypical use, just awesome. Comprehensive use, good. Information acquisition, just rotten. Yeah, MC?
Quick question on that convergent validity issue.
Can you speak up just a little bit?
Yeah, quick
Thanks.
question on the convergent validity issue. Is the average that will come out of these latent factors the same as the Chromebox alpha that's going to show up?
Similar, yeah, very similar.
Okay.
Yeah, yeah.
So you should be able to know your convergent validity roughly from this.
Just from, yeah, you're eyeballing it right here. Okay. Yes.
You could also have some items loading the same factor.
Yes.
It might be a wording issue or issue of too high correlation.
So let's deal with that. So we see that information acquisition loads in 2 places. Well, which one does it belong to? It's loading almost the same level on factor 1 and on factor 7. Factor 1 is decision quality. So a couple things. Is information acquisition the same as decision quality? It's obviously related, but not really the same thing. We want this to be a separate thing. In our model, they're both dependent variables, separate dependent variables. So we want to find some discriminants between these two. We want 2 distinct, different constructs. So we need to fiddle with it a bit. Let's go fiddle, unless there are other questions.
Do you want to hold on to every item
Possible.
as possible?
To some extent. If you're using established scales, definitely. Hold on to every item you possibly can. If you threw in a ton of items and you were just sort of exploring, trying to create new scales, try to get to about 4. If you're creating a new scale yourself. 4, 5, it's good. And nobody knows the difference.
Were these all created or were these all?
Most of these were, let's see, I'll tell you. Decision quality is created based on external literature, but it is we created it ourselves. Usefulness existing, joy existing, playful existing. We created atypical use, comprehensive use, and information acquisition was based on something else. So about half and half.
What about efficacy?
Efficacy exists. Bandura,
Okay.
yeah, is an author. Bandura is the guy who wrote on that one. Okay. Yes?
So I have 2 constructs loading on itself.
Yes. Oh, you have a set of items loading on 2 constructs?
I have decision quality and info acquisition.
All in the same one. That's what we have. So you're in luck. Yeah. So there are multiple things we can do here. We can reduce this to 6 factors and see if that works out better if we're totally cool with merging decision quality and information acquisition. If we're fixed on this theory, though, that we have 7 separate factors, we can fiddle with it a bit. And I think we are a little more fixed on not merging them. So here's what I would do. I would do a separate factor analysis on just decision quality and information acquisition. So get rid of everything else and just do info acquisition and decision quality. Don't change anything else. Just leave it like that. We're already doing this freely, unconstrained, and hit OK. And let's see what we come up with. Ooh, decision quality 8.27. Yikes. We came out with 2 factors, which is what we expected. That's good. Model fit, not great. That's around 5. 15%, whoever asked on remotely, look, we have 15% non-redundant residuals, which is a problem. And here we go. Actually, they load fairly well, except decision quality 6. Ha! Oh, and 8. So what I would do is get rid of 6, because 6 is obviously the one that's causing the correlation between information acquisition and decision quality. So I'm going to drop 6 right now. That was decision quality 6. Adios. Run again. Jump straight to the pattern matrix. And now decision quality 1 is loading on both sides. So another one that's causing this lack of discriminants between the two. And we want to try to discriminate between these two factors as much as possible. So I'm going to drop decision quality 1.
And 6 already, right?
Quick question,
Yep.
though.
Yes.
If you drop decision quality 1,
Yes.
do you want to try DQ8 and see what happens?
My goal right now is to increase distance between the two factors.
Right.
So anything that's cross-loading, I want to get rid of that first.
I'm asking you because before we edited the first button where we just removed, we didn't have a cross-loading on DQ1.
Right. Every time we add or remove an item, this is an interdependent network of effects. And so when we take somebody out, it changes those relationships, those interdependent relationships. Right. So the nature of the construct is slightly shifting.
Shifted, right.
Yeah.
But I was thinking because we had an issue with DQ8 before,
yeah.
we probably want to try that and see.
I'm guessing we'll take out DQ8 anyway because it's loading so poorly.
Okay.
Yeah.
So I'm doing this a little bit differently because I like PAF a little better.
Sure.
And we saw that there
are small differences.
Yeah. Issues. But so when we drop DQ1 out of PAF, everything works out. Now there's some low
Really?
loadings.
Cool.
Yeah. So
Good to know. Well, we're about to do it. We're going to drop DQ1.
And
then did you have a question?
Yeah, so sometimes isn't it valid for there to be cross loadings? I mean,
Good question. Conceptually, we might expect these items to load together because they're worded the same or they're conceptually the same question. But the problem is when we're testing our structural model, our causal model, if we're saying this predicts this, but an item here is the same as an item here, then we're predicting something with itself, essentially, which is invalid. We have to have distinct constructs in order to make causal claims. Does that make sense? Good.
Even if the value was below 2.2, decision 41 has already a kurtosis issue, so we could drop it.
Oh, we found one with a kurtosis issue that's in there still?
1.3.
Kurtosis. Info acquisition 3.
No, decision 41.
Decision quality 1. I'm getting rid of it anyway. Everybody's shouting for it. I'm going to do it. There we go. All right. Here we go. That's looking better. Now, decision quality 8 is still a pretty low loading. Look at info acquisition, though. That's much stronger.
Yeah.
So I am going to go ahead right now and get rid of decision quality 8. That's just far too low. Yes?
So basically anything below 0.4.
Below 0.4, below 0.5 is my preference, if possible. And especially since these are items I made up, this is a new scale, we're free to just trim as much as we please, down to maybe 3.
Does it go differently when you put them back together?
Yes, so we're going to put them all back together in just a sec. All right, I got rid of DQ8. We're looking a lot better, We see InfoAct 5 and DQ7 are still kind of low. Let's go through those back with everybody else and see how they play. Yeah, MC?
What if your best pattern matrix has an unequal number of items per factor? So
Oh, that's fine. You could have one with 3, one with 10.
And as long as you have above 3 but below 5.
Above 3 but below 12-ish.
You said ideal is 4.
The ideal is 4, yeah. But if it's an existing scale,
With a beautiful pattern matrix where you have good, averages of 0.7 per latent factor, but then have like 4, 4, 4, and then a 3 with each of the factors.
oh, that's fine. Yeah, that's fine. Yeah.
So, but if the factor itself doesn't have over 0.7, that's...
If it's not averaging out to 0.7, you're going to have trouble in the future.
So you just want to get rid of it.
No, wait till the CFA to get rid of it. Unless it's really bad, like all of them are 0.3s.
Oh.
Yeah. Wait, if you're averaging out to 0.5 or more, keep it till the CFA. Yeah.
Say that each factor has to have 12 or less loading items?
Ideally, I mean, 12 is a really high number. More than 3 would be nice. 3 or more would be nice.
But there's a maximum?
No, there is no maximum. I've seen people with 20 on a single item, or a single factor, excuse me. All right, I'm going to throw these back in.
What does the selection variable do again? Just have that as a quick note.
Selection variable. Oh, if you want to split it up by groups, so say male or female, yeah. Okay, I'm going to throw these all back in, except remember, don't throw in decision qualities or any info acq we might have dropped. I don't think we dropped any info acquisition, actually. Okay, I'm going to run it and jump straight to the pattern matrix and look at those two that we had trouble with. Decision quality. Hey, looking pretty good. And notice there's nothing below 0.5. There was when we did it with just the 2, but now it's bumped up. Info acquisition, looking much better. Number 5 is borderline. I'm going to try removing it and see if it helps. If it doesn't, I'll put it back in. So that's number 5, info acq 5.
Could it be an item without any loading whatsoever?
Ah, get rid of it. It's useless. It also has a low communality. Yeah. Yes?
And James, you do have cross-loading, but if you have, on your primary load, you have a decent number of 5 or above, and your secondary loading has a degree of separation more than 0.2, then I would be of the mind to write it up and keep it.
Yeah.
Is that?
You want to keep as much as you can. You're fighting for these items,
Yeah.
not trying to break them down.
Yeah.
Keep them, okay, if the difference is that that's multiple cross-loading.
Okay, let's talk about cross-loadings. One thing, I tried removing information acquisition 5. It actually made things worse, so I put it back in. So here it is. Okay, let's talk about cross-loadings.
Oh, sorry, how did it make it worse? I thought it made it better.
It dropped a couple of the other loadings down to 0.5. Yes?
But you told just before that doesn't average out 0.7.
It doesn't, not yet.
We will have a problem for this.
We might. Amos tends to inflate these values just a little bit. So we might see all of these jump up to 0.7, 0.6. Yeah. Let's talk about cross-loadings. Let's go up to this pattern matrix that we had earlier. Woo. Right. So one of these ones up here. You can just watch at this point. You don't have to follow along here. Here we go. Factor analysis, pattern matrix. Nope, not that one. This one. Okay. See these ones down here? These ones are cross-loading. Now, if they all of them are really cross-loading. If I show you, if I don't suppress small coefficients over here, if I don't suppress small coefficients, notice they will all cross-load. If I go down to the pattern matrix, here's what the pattern matrix really looks like. That's why we suppress small coefficients. But they're all cross-loading. They all relate to each other somehow, to whatever extent. We just see that these values are much stronger than these values. So the question is, how much can they cross-load? Down here at the bottom, info acquisition, those, oh, we got rid of those 4, so we'll let me suppress again. Factor analysis, options, suppress. I'm going to suppress at 0.2 and see what we get. Pattern matrix. And here we go. Here are a couple cross-loadings here. So decision quality loads also on factor 7 at a 0.205. Is that a problem? The answer is no. It needs to be about 0.2 away. In fact, there are some articles, I think it's Geffen and Straub, 2008, that say you can actually be within 0.1 away. I definitely prefer 0.2, otherwise you end up with discriminant validity issues.
What needs to be 0.2 away?
These loadings. So here's 0.514, and here's 0.205 on the same item, different factors. So this one, it belongs with the higher loading, factor 5, but it also loads on factor 7. But since they're more than 0.2 difference from each other, we're okay. If they were within 0.2, then we might have a problem. And we'd want to probably delete that one because it's going to cause discriminant validity issues.
So before we move on, we want to get rid of things that are closer than just 0.3 or
0.2. 0.2 away, yeah. Again, with this one, information acquisition, it's more than 0.2 difference, so we're okay. Again, this is why I suppress small coefficients at 0.3, because I'm looking for anything above 0.5 to keep. So if it's less than 0.3, I don't care if it's cross-loading, because I'm only keeping things with 0.5 loading or higher. So that's 0.3 to 0.5 is 0.2 away. Oh. Yes?
Obviously, there's
Can
more
we
than one
keep
way
an
to do
item
this.
if it is loading 1.04 or 1.05?
Oh, extreme loadings? Okay, if you're having extreme loadings, like 1 point whatever, use Varimax rotation.
Okay.
Yeah, use Varimax, and that'll fix it. It suppresses it a little bit. Yes.
Obviously, there's more than one way to skin this cat.
Yes.
And justify it.
Yes, oh yeah. You could come out with a different solution than I did if we didn't do this together. And that's often the case. And it depends on which items I take out in which order, how many factors I decide to extract. This is very subjective while still being statistics. Yes.
If you have two groups of items on one factor,
Yes.
is that still cross-loading?
Yes, that is major cross-loading, and what you'll want to do then is do what we did with information acquisition and decision quality, do just a factor analysis with those two constructs, and see how you can separate them. Okay. Yes?
If you have a factor that has 4 items left after you've turned everything off,
Mm-hmm.
but one of them is like 0.365, is it worth keeping or getting rid of it and getting down to 3?
See if getting rid of it helps. If not, keep it. If it does help, drop it. Yeah. And once we move to AMOS, move to the confirmatory factor analysis, that 0.3 will most likely pump up to about 0.4 something.
So it might be worth keeping.
It might be worth keeping. 0.4 is still pretty low.
And then you have the average too.
Yeah. But it is. But what's that saying? It's saying we don't have good reliability. We don't have good convergence. We have these 3 items moving together and then this sort of other guy not moving with the pack. So is this one really capturing what we intended to capture? Hard to know.
3 is, I mean, we're getting down to minimum.
Yeah,
3, right?
but don't go less than 3 if you can help it. I've seen 2. Often people use 2, but it's not very stable.
So,
Yeah.
as I'm looking at, on the screen up here, info act 2, 3, 1, 4, and 5.
Yeah.
If you add up your loadings
Yeah.
and divide by the number of
Yeah. If you
loadings,
average the loadings,
there might
we're less than 0.7.
You're less than
But again, in AMOS, it's going to inflate them just slightly. So we're probably all right.
So
Go ahead.
for our own research, when we have established scales we're using, a lot of those scales might have 4 items.
Yeah.
All right? And they, let's say, don't load to the 0.7.
Yeah.
And, there's a specific factor there. Can you just go and use that as an exception in research? Or?
And say we kept it because it's an established scale.
Yeah.
That is one approach. If it has a lot more items, like 10, you can weed it out and
Right.
say,
But if you have
sorry, it's an established scale, but it didn't load with my
Right.
specific sample.
So if you have 4 and you went down to 3 or 2, is it better to go to 3 or 2, or is it better to keep it at 4?
Go to 3. Hopefully it works. If not, run it. The issue you're going to have is if there's not convergence, again, you have an inconsistent set of movement variance, and how are you going to predict something else moving with something that's not moving consistently with each other? You can't. And so what you're going to find is if you have a non-convergent factor, you will not find any significant effects out of that factor. Yeah. So you're going to end up dropping it eventually. Yeah.
What about negative loading?
One moment remotely. We have a local question, then I'll get to you.
Negative loading?
Negative loadings. Okay. You will have negative loadings in cross loadings, but if you have a negative loading on the principal factor, what that means is that item moves inversely, like our ADE or whatever we had up on the moving blocks. One of them is moving opposite to the others. You'll want to reverse that item because it's probably a reverse coded question is my guess. So reverse that item, subtract it from 1 more than the scale size. So if you're on a 5-point Likert scale, subtract from 6. Yeah, and that's why it moves inversely. If it's not a reverse coded question and it's moving inversely, that's bizarre. I don't know why that's happening, and you should get rid of it probably because it's a problem. Or you have some weird outliers. Okay, anything else? Yes?
When you remove it, Even though you didn't remove it here in the EFA?
Yeah, you can definitely remove during the CFA. I almost always end up having to remove something in the CFA. Yeah. Okay, there was a question remotely.
If I started with maximum likelihood and Promax, can I then, after that, after I remove some of the items, then I use the maximum likelihood and Verimax? What you just
Oh yeah, that's fine. Whatever you end up using, whatever your final model is, you would report that, if you reported it at all. I almost never report what kind of rotation I used. I mean, that's just boring.
So you can change the rotation every time you remove the items?
Yes, you can. Yep. Okay. Any other questions so far? There's plenty more to discuss. So.
You came up with 8 factors, letting it freely, not constraining it. Is there a reason why you want to constrain it down to 7 or?
If you thought for sure that there were supposed to be 7, you can constrain it to 7. What you might find is poor model fit in the end. If it said there were if it said there were 8, but you wanted 7, you might just have model fit issues later on.
Are you going to talk more about rotation?
No, but there are some slides on it. Yeah. Refer to the slides.
Are there reasons you'd want to look at it without rotation first?
There is a reason. If you're looking at common variance, there's something called a Harman single factor test, and you do an unrotated solution on a single factor to see if there's some weird common variance that you weren't anticipating. Yeah.
James,
Harman's, Harman.
So the result of these operations would improve the non-redundant residuals, but it's still pretty high.
Oh, 3%'s great. We have it's 3%, not 26.
Oh. Okay.
Yeah, we're good. Yeah. Okay. Any other questions before I move forward?
What is that 3%?
3% is the non-redundant residuals, the amount of error, essentially. Okay. Yay. We found a good solution. Let's talk about convergent validity. We have, hopefully, some convergent validity. We see the items load together, which is good. They load pretty highly, averaging out roughly above 0.7 for the most part, which is great. We have discriminant validity because they're not cross-loading anywhere. So they are distinct factors, which is good. We also can look at convergent or discriminant validity here in this table. In this factor correlation matrix, this says for each factor, how are the factors correlating to each other? We want them to be less than 0.7. And it looks like we're pretty good, except here this 0.655 is getting close. That's factor 5 and factor 7. I'm guessing those are information acquisition and decision quality. Yep. So we knew that we had some discriminant validity issues there to begin with. We've sort of cleaned them up, but it's still borderline. 655 is pretty close to 0.7. So we have convergent discriminant validity. Let's go look at reliability. So we need to calculate a Cronbach's alpha, a value for the reliability of these factors. The Cronbach's alpha says how consistent are they moving together. Not how tightly, but how consistently. And so you always have to report a Cronbach's alpha. The way you do that is you go analyze, scale, scale, reliability. And let's see what we have. Usefulness, I'm just going to keep the pattern matrix in the background. We have usefulness, 1 through 7. We didn't drop anything from usefulness, so let's go find usefulness and throw it in there, 1 through 7. And in the statistics, oh, it popped up. Bother. 1 moment. It is hiding blue. Come on. There it is, hiding up there. Okay. This is a cute picture. All right, let's see. Then Windows P. There we go. And blue again. Come on. There we go. Okay. In the statistics box, There's this thing, or scale if item deleted. What this is going to do is going to produce a Cronbach's alpha and then say, if you deleted this item, what would your Cronbach's alpha be? And if you deleted that item, what would it be? So to see if we can improve our reliability. Sorry, was that for us? Oh, okay. Continue. And okay. And the Cronbach's alpha is 0.941. That's really good. That's really good. That's we want above 0.7. So this is fantastic. But notice, if we got rid of usefulness 7, we could bump it up to 0.942. Should we? No. I mean, seriously? Are you that greedy? I mean, you got a 0.941. Be happy. You know, just be content with things. 0.942 is great. It would make for a more consistent construct, but it's 0.01 higher. I wouldn't mess with it. Especially if this is an established scale, which it is. Definitely, you wouldn't delete it at this point.
Is there a ceiling that tells us Cronbach's alpha is so high that our items are redundant?
Well, you sort of want them to be redundant to some extent, because what we have is a reflective scale. We're trying to capture this thing with these things. So you notice whenever you take a survey, you think, haven't I answered this question already? I swear I answered this question like 3 times already. Yep. And it's because you have a very similar question. And so we're trying to capture this in many different ways with the same thing. Yeah. So, what you'll see, though, if you really want to know, you'll see in the loadings on your pattern matrix, you'll see a 1.0 or a 0.998 or something super high on 2 of them, and they'll be identical. Yeah. Yes?
Getting the Cronbach alpha, do you have to do it by construct category? Why not do it?
You can't do them all at the same time. It won't do it. Yeah. I made a tool that will, though. It's in my stats tools package. I'll show you tomorrow. It does actually composite reliability instead of Cronbach's alpha, which is actually more recent, more reliable measure of reliability because it takes into account error. Anyway, I'll show it to you tomorrow. Let's do this one more time, or twice more. Once for decision quality, once for information acquisition. Those were the 2 we were kind of worried about. And you definitely want to do it for anything in the pattern matrix. Well, you got to do it for all of them, but you definitely want to do it for anything that loads low, like this comp latent. All the loadings are kind of low, or where you have kind of disparate loadings. Here you have up to 0.9 but down to 0.5. That's kind of weird. So I'm going to do it for information acquisition, decision quality, reliability. Decision quality, we only kept, and you only do it for the ones you keep. So that's 2, 3, 4, 5, 7. 2, 3, 4, 5, and 7. And okay. And 8, 9, 7 is great. Could we improve it? No, we couldn't. And last one, information acquisition.
James, what are you clicking on under statistics? Is it correlations or keep it at height?
I'll show you. One moment. Did we get rid of any InfoAc? No. Okay. In statistics, I only clicked on scale if item deleted. That's it. Continue and continue. And 0.834, these are all great. We could actually improve it by getting rid of info acquisition 8. Or 5, excuse me, which was the one that was loading kind of poorly, right? InfoAc 5, yeah. So we could actually improve it by dropping that, which we might end up doing in the CFA. But for now, I think we're fine. Wow.
And so, any of our factors which is going back to everyone.
You would do, yeah, you need to do a Cronbach's alpha for every single factor.
And if you pulled out an item from there, you want to add it back in the way you said before, what is it deleted? Or is it just, you want to go back, in other words, you see there, like, decision quality 7.
Yeah.
Okay.
If I'd removed that?
If you'd removed that, would you want to show the contrast in the analysis between...
Okay, so let's say I remove something after doing a reliability test. I'd want to go rerun the pattern matrix, go rerun the exploratory factor analysis. So whatever our final measurement model is, run that through the exploratory factor analysis, get that pattern matrix to come out. Because you'll be using this later to build your confirmatory factor analysis.
Right. But there's no, once you pull them out, there's no reason to go back and get a convex on.
No, we already know what it is. It's 0.8 or whatever it said it would be. Yeah, 0.838. What do you report? How do you report the Cronbach's alpha? Let me show you an example. There's a paper I wrote with Steve. Let's see, I think it's this one. And hopefully it'll be accepted. Let's see. Blah, 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 blah. Oh, we put it down in the appendices. Okay. Here we go. So here's our pattern matrix, which is the only thing I stuck in the appendix, by the way. The only thing. You don't need a ton of stuff down here. But here's the Cronbach's alpha. I just added it to the pattern matrix. So that's a convenient way to do it. Just make sure it is bolded or somehow highlighted, or else nobody will catch it. Yeah?
As we go along, can you tell us what we should include in the text as for tables?
Yeah, you know what? You want to just show you real quick? Or as we go along, I can talk about it, but sorry, you're probably getting dizzy. Okay. There are some critical tables you need to include in a study. One is demographics. So how is your data distributed? If you collected from CEOs, you know, what was their tenure? How long have they been with the company? What industry are they in? Just some basic demographic variables. Gender is most common to report. Things like that. So for this stuff, I reported age, education, experience, and use, and gender. And you would report min, max, mean, and standard deviation, just so that they know you have good sampling going on.
This is in the slides.
No, this one isn't. Do you want me to put this paper? This is probably a good example of, I'll put it in Dropbox. But it's not published yet, so please don't go submit it somewhere. Yeah.
Don't worry, Ted's not here.
Don't worry about me. Nobody will believe that I do that one.
Like for real, be nice. This isn't published, so I'll stick this in. Steve, is that okay?
That's totally fine.
Okay.
As long as you don't publish it, because I want to go to New Zealand.
Yeah. So we're publishing this hopefully at ISIS, so we can go to New Zealand. That's the real reason we're submitting this to ISIS. I know. Okay. Let me do that right now. File, save as, and stick it in the Dropbox folder. Browse to Dropbox. And SEM BootCamp, wherever you are. And I'll put it in references. This is a don't distribute or try to publish. There we go.
James?
Yes?
An easy thing to do is use a watermark of draft and then save it as PDF and nobody can mess with it.
Oh, that's brilliant. I should do that before they all copy it. All right. I trust you. I'll catch you. So don't. I'll leave it like this, though, so you can copy tables, which is nice. You need a construct correlation matrix, always, where you have the correlations between the constructs. And I have a tool that makes this for you with the square root of the AVE on the diagonal, which we'll talk about tomorrow. You need model fit, always. And you do that for both your measurement model and your structural model. I usually only report in a table the measurement model, then I say in words right here for the structural model. I usually report whatever figures I need, and then a summary of results. That's it. That's a full-blown study with second-order factors and stuff. So not that complex. Okay. Of course, this is for conferences.
And the pattern matrix.
Yeah, and then the pattern matrix at the bottom. I usually don't include the pattern matrix in the main body text because it's really cumbersome. And people aren't interested in it unless they're statistically savvy.
How about the models?
I only included the two I needed. I'm doing mediation in this one, so I included one without the mediator, one with the mediator. Yeah. You would never include like 10 models though, every step of the way. Nobody wants to know your journey to get to your final model. Okay.
I like you putting significance on your weights.
That's the way to roll. Yes. I think I had to do that through PowerPoint and then copy it over. I tried to find a way to do it in Amos. I can't figure it out. Yeah. Okay. Moving forward. Sorry about all that. Hopefully it's helpful. Let's go to the slides and see if I forgot anything. And blue. Okay. Here we go. We got up to here. And we talked about this, actually. And now here we are. FYI, this is just for you. I talked about what is a KMO and a Bartlett's and what is, what we should be. All the thresholds, all the cutoffs, the rules of thumb, they're all in here. So you don't have to take notes on that now that you have. It's also in the video. We talked about that. We talked about that, and that, and that, and that, and that. How many factors do you extract? Good question. I always let it run freely first, just to see what's going to happen, because that's the best fitting model. And I want to know if my a priori theory of measurement is going to match what is extracted. And then I usually try to find a way to make it match, which is the number based on theory, my a priori theory. Let's see. Yep, try multiple approaches, but if you have an a priori theory like we do, we have 7 constructs. Eventually you need to try to get it down to those 7 constructs if possible, unless you discover something totally new, which we didn't. Just more pictures to help you out. Pattern matrix. The things to remember, each item has to have a home factor. Each factor has to have its own items. Oftentimes, you'll run a pattern matrix and you'll have a factor with items on it loading, but they're the cross-loading. They're the low loadings in the cross-loadings. So you have like a factor 2 that has these 2 items loading at 0.7. You have a factor 12, which has these same 2 items loading at a 0.2. They're not substantial. You have to get rid of that empty factor. Each factor has to have substantial items. Make sure things make sense, obviously. This one, I don't know if you can see this. It's kind of small. But I was not expecting BM 5 and 6 and BM 1 and 2 to load together when I ran this. This was a surprise to me. And so I had to go back to the survey and find out what these items were and why they were loading together. And eventually, it made sense. There was some underlying theme, something about stress. And so I left them that way. So there needs to be a good underlying theme if they do load together unexpectedly. Oh, this is useful. This is very useful. Joe Hare, he's awesome. He has a book. He has several articles and several books on statistics. He says that depending on your sample size, you can actually have pattern matrix loadings very low if you have a really high sample size, because effects are stronger when you have a high sample size. So you can have a 0.3 loading if you have a sample size of 350. That's what we have. We have 350 plus. So we could actually deal with a sample size of or a loading on our pattern matrix of 0.3 or more. But realize that you're probably going to have a poor Cronbach's alpha, and when we move on to confirmatory factor analysis, you're not going to achieve convergent validity. So you can have those low loadings, but it's a problem. But if you wanted to keep them, there's your argument right there. Joe Hare says I can, and he's the expert.
So it just has to be the 0.7. I'm sorry, it just has to be the 0.7 average.
That's the ideal.
Right?
Yeah. Or more, yes.
Is parsimony an issue with the number of factors, assuming that you get at least 60%?
Sure, parsimony is always an issue. Let's say you're doing something with 100 items that you could do with 50 items. Do it with 50 if you can. Yeah. Yeah.
It starts to get pretty low like that. It's probably likely that you're going to have cross-loading
That's significantly close.
Or that it's not going to be far enough.
Exactly, yeah. If you have low loadings, the cross loadings tend to be more.
So anytime there's a cross-loading, you want to get that.
Pretty much.
And
Because if you're down to 0.3, anything above a 0.1 is trouble. Yeah. Although if you have a sample size this large, you can probably push that up to a 0.1 difference. Yeah. But again, you run into discriminant validity issues. Adequacy we talked about. Yep, all of that we did. I say here greater than 0.5 is better, but really you can get down to 0.4, even 0.3, depending on your sample size. Validity, do they make sense? We talked about. Convergent, discriminant, we talked about. All that. Good, we talked about all that. Reliability. There's another approach to reliability that not many people do. And so I never teach it, but there's a way to do it. You just run 2 EFAs with randomly sampled data from your data set. So randomly sample 50%, and then randomly sample 50% again. Do an EFA with each. If you come out to the same, roughly the same factor structure, you have pretty reliable factors.
So it could be a lot easier to find if you got 7, 8 factors. It's a lot easier than going through each time.
But if you don't report Cronbach's alpha, reviewers will come back and say, hey, where's your Cronbach's alpha? If you don't report splitting it up randomly and doing 2 EFAs, nobody will ask. Yeah. So that's why everybody just defaults to Cronbach's alpha. It's just the established method. It also provides a number for you rather than you're sort of eyeballing it when you do 2 different EFAs. You're saying, yeah, it looks about the same, or yeah, all these items loaded on the same factors.
You split your data set in half. Each one will need to have the adequate number of.
Yeah, that's the other thing. You're reducing your sample size by half. Yeah. So it could be a problem. You might not be able to do it. So just do the Cronbach's alpha. But there is that other way, just FYI. Okay, there is time. Oh, we have tons of time. This is great. Okay.
James?
Yeah.
Where exactly on Dropbox did you put it? The paper you just posted?
It just went for the overall.
In the references folder. References folder. You're welcome. Yes? Yeah, we'll break. There's one question real quick. Yes?
When we remove one of the items, do we have to mention the reason why did we remove
Oh,
the item?
yes. If you remove items during the EFA, you need to say why. Usually, the most common reasons are poor loadings. It didn't load, or cross loadings were too strong. Those are the 2 main reasons.
What if it is affecting other factors to load? I mean,
Yeah, so due to some sort of discriminant validity, some sort of cross-loading issue?
no, let's say there is a factor that is so strong that making other factor to cross-load on, like...
Yeah, you could just say, what you would say is just due to problematic cross-loadings. Or too influential, something like that. Let's have a 10-minute break. We'll come back here about 1:45, and then we'll talk about formative versus reflective constructs. And then go from there. Let me check on Hangouts here. Cool. Let me pause. All right, let's come back. All right, let's get started. I think we're still missing a few, but they'll trickle in. Let's see. Oh, did my mic mute again? Just a moment. Okay, okay. Someone keeps muting me. Don't mute me. Mute yourself, remote folks. Okay. I slightly take offense at that. There we go. William is what it says. Bill, don't mute me. Thanks. All right. That's funny. Okay. So what we were going to do is start on... Wait. Why isn't that working? Escape. There we go. Oh. Duplicate. Blue. Okay, Bill, stop muting me, please. Oh, he can't hear me. Bill, stop muting me, please. You keep muting me instead of yourself. So to mute yourself, click at the mute on the top of your screen, not the mute on my little box here. Thanks. If you keep muting me, then other people can't hear me. Thanks. I'll be watching. Okay. Hey, if I get muted again, somebody holler, because I won't be able to see. I'll be doing other things. So if I get muted again, just holler and I'll hear you. Okay. Let's see. PowerPoint. Here we are. If there's time, formative versus reflective, and start on the CFA or do some exercises. So, formative versus reflective. Is that too small? A little bit. So, we'll go back to here. Sorry, blue. Here we go. Nope. We're going to make it. There we go. Okay. There are two different kinds of latent constructs. One is formative and one is reflective. We've so far dealt only with reflective constructs. Reflective constructs are somebody remotely, it sounds like you're playing ping pong with your microphone. If you wouldn't mind muting your own mic, that'd be fantastic. Thanks. Okay. Reflective factors are where you have individual items that are sort of the same. Sort of like we're talking about here, they sort of measure the same thing in the same way. And the indicators, the items, are interchangeable. If you drop one of them, it's not going to make a big difference to the factor. We dropped a couple of the decision quality items. It's not going to change decision quality that much. But we're asking the same thing with all those questions. Whereas with a formative factor, you can't see my mouse, that's right. With a formative factor, the items are not interchangeable. These are different things. They're different parts of a thing. So here's an example. We have, oh, those didn't format very well. Okay, a reflective construct called diet, where all these items should be interchangeable, right? I eat healthy food, I do not eat much junk food, I have a balanced diet. These are all asking sort of the exact same thing. And if I do one of them, I'm going to do the other one. If I eat healthy food, I'm going to have a balanced diet. If I have a balanced diet, I'm not going to eat much junk food. They're all sort of interchangeable, asking the exact same thing. Whereas if I have a construct called health, and it's formative, I ask sort of different things. I have a balanced diet. That's a part of being healthy. I exercise regularly. That's another part of being healthy. It's another dimension of being healthy. And I get sufficient sleep each night. False statement, but it is another dimension of health. If you take away one of them, it sort of changes the nature of what you're capturing. And so the construct depends on these multiple dimensions. Now, these also don't have to, they don't necessarily have to correlate. With these ones, again, if we do one, we probably do the others on the reflective side. Whereas with the formative, if I have a balanced diet, I don't necessarily exercise regularly. Or if I exercise regularly, I don't necessarily sleep all the time or sleep well. They're not necessarily correlated. They're just different dimensions of this thing. If I do them all, I'm probably very healthy. Now, an EFA expects items to correlate. It's built off of the covariance matrix, which is like correlations if you square them. So can you include formative factors in an exploratory factor analysis? No, not effectively. You can't. So what do? You could use PCA. Okay, this is a workaround. Yeah, if you use PCA, principal components analysis, rather than principal axis factoring or maximum likelihood, then it's easier to include formative factors because PCA maximizes the potential correlations. That is one way to do it. Another way is don't use formative factors. That's the easiest way, probably. But sometimes it's better to use formative factors. What's a better measure of health? 3 items that ask if you're healthy? or 3 items that capture the various dimensions of health. I think this is a more robust, more complete measure of health when you do it formatively. It just makes it difficult to analyze further on because we don't require the items to be correlated. We cannot come up with a measure for convergent validity. We don't expect them to be convergent. They can be, but we don't expect it. And so there is no measure of convergent validity. There's also no measure of model fit, which we haven't talked about much. But we talked about briefly with the chi-square of degrees of freedom, right? There is no expectation of model fit. So they're slightly problematic. Amos, which we'll use tomorrow, maybe a little bit today if we have time, Amos does not handle formative factors. It only handles reflective ones. If you want to deal with formative, you need to use a PLS, partial least squares software, which if we have time Saturday, I'll show you. And if you want to use it on Saturday, you'll need to download it starting today because you have a 24-hour grace period or something like that where they have to approve you individually. It makes no sense to me. They're just going to approve you anyway, so why not do it automatically? Anyway, so that's that.
Dr. James?
Yes, Dr. James. Sorry.
Why there is if you see in the formative there is error, but in the reflective there is no error.
Yeah, where's the error? So the error on a reflective is on the items themselves. The error on a formative is on the latent construct. Why is this? Because it's the thing you're predicting that has the error. That's just the way it rolls. The thing you're predicting has error. In this case, we're quote-unquote predicting. The arrow is going into the boxes here, the items. So they receive the error term. We count for the error in their prediction. Whereas we need to count for the error in predicting the latent construct when it's formative because the arrow is going into it. We're predicting it.
It reminds me of the setup that we're doing for the common factor in CFA.
Yeah.
Does that,
No.
There is no way we can use some version of that for doing
Formative and the CMB analysis, no, different. Yeah. Yes?
Is the error, the aggregate error equivalent if it is on the item 1 in the reflective and
Versus this?
yeah.
Will they come out to roughly the same thing?
Yeah, is there equivalency?
I have no idea. No idea whatsoever. I can't even think through that. If we had the same items, R1 through 3, and we just switch the arrows around, my initial guess is yes, it would be fairly similar but not identical. But that's just a guess. I have no idea. Yes?
So with formative, could you just use a regular multilinear regression to predict health?
Health is nothing right now. Health doesn't exist, so we can't, as far as I understand your question. Health doesn't exist anywhere. It's this thing we're trying to figure out with these 3 items. And so the way to model this, if we get to PLS, I'll show you. But what you have to do is actually to show you a more hands-on thing, the way you model it. You can't model it in Amos like this. It won't work. It says health doesn't exist. What is health? Yeah. Okay. Sorry, that wasn't a very good answer. But if we get if we get to PLS, it'll connect. Any other questions before we move on? Okay. Okay. Here's a question for you. Do you want to move straight on to CFA? It's a massive topic, or do you want to practice this or work on your own thing? I hear a lot of CFA. Anyone want to? Any opposing votes? Because it's all up to you. All right. All right, let's start on CFA. We're not going to get very far, but we'll get through some of the conceptual, and then hopefully we'll finish tomorrow early, which will let us finish Saturday early, which will let us get to PLS and cluster analysis and stuff like that. Or let us go hike in a canyon. That'd be fun too. By the way, I should cover that right now. If you're not doing something awesome while you're here in Utah, you are wasting your trip. I mean, this is a great seminar and all, or workshop, I think is what we're supposed to call it. This is a great workshop and all, but if you're missing out on hiking or skydiving or whatever it is you want to do here, you're really missing out. It just snowed this morning. Like, go do something fun. And if you don't know what to do, come ask one of the locals. Locals, raise your hand real quick. Okay. What is fun to do in Utah? Oh my goodness.
There is fishing, there's hiking, there's snowboarding, there's skiing, there's cave exploration.
Oh, caves here are great.
Yeah, go to Mount Tent, go do a 4-hour walk if you want to keep up like on Sunday or Monday, and then go through the caving system.
Caves are fun. There's a lot of hang gliding, paragliding at the point of the mountain. There's Thanksgiving Point. Oh, we have the best natural history museum in the U.S. We have.
I was asking about the nightlife.
The nightlife?
No.
Sundance and Park City is all I can say on that one. Yeah.
Asking a bunch of obvious people.
Yeah, a bunch of young Mormon folk. Yeah, but yeah, if you want some nightlife, Park City, Sundance, and Salt Lake City. But Thanksgiving Point, Temple Square in Salt Lake City. You should hit Temple Square if you haven't hit it yet. It's just amazing. Huh? And the mall next door to Temple Square, if you like malls. It's pretty nice. Oh yeah, we have lots of waterfalls. Boy, there's everything, except nightlife. Yeah. Yes.
You have slides to remind us of adequacy, reliability, all
Yeah, all that stuff was up here. Yeah. Okay. Yes.
I have forgot to ask a question about the pattern mappings. Can you have a control variable as a factor?
Yes. Anything latent you can have in the factor analysis. Anything. And the safe route is to include it. A reviewer would never say, you included a control in your EFA, you shouldn't have done that. But they might say, your control was latent, why wasn't it included in the EFA? So, because what if your control is the same thing as your dependent variable? Then we have a problem.
We might get to this in EOS, but I just have a question about the direction of the arrows.
Yeah.
Here, so for the reflective, are you basically saying that this latent variable manifests in these items, and then with the formative, with these factors, then
Are dimensions of.
Okay.
Yeah, good. Yeah, manifestations and dimensions. That's the right wording.
So is that more like a conceptual argument then that you have to make in terms of the arrow direction?
The determining the arrow direction is a lot. The easiest way is seeing if they're interchangeable items. If the items are totally interchangeable, arrows point towards the items. If the items are dimensions, different distinct dimensions, then arrows point towards the factor. Yeah. And if you can ever help it, just use reflective. It just makes life easier. It's also easier to publish with reflective. People don't know how we've had formative measures around for 30 years and have been using PLS for 30 years, and yet people still don't know how to evaluate formative factors. So go with reflective if you can. CFA. Let's have some fun. Oh, orphan child. Sorry if any of you are orphans. I mean, figure of speech. All right. Let me close this. You can't see my screen, can you? CFA, day 2. Who deleted day 4 or day 3? Come on, people. Good thing I made a backup. Thank goodness. Somebody, you can't see this. Yeah, somebody deleted day 3. Luckily, I have day 2, which is all I need right now. I was editing day 3 this morning. All right. Okay. Here we go. CFA. F5. Let's see how far we can get. Confirmatory factor analysis. So today we've been exploring the measurement model, and now we're going to go confirm that measurement model. CFA is good for a ton of stuff, and that's why we were going to spend a whole day on it. You do so much stuff in the CFA. For those of you who have done quantitative studies before, you spend 90% of your time, maybe 95% of your time, building up to testing your structural model. You don't test any hypotheses until like the last 5%. You spend all your time building your survey, pre-testing it, getting data, cleaning it, exploring it, and then confirming the factor structure. And then finally, after you do all this junk, which is necessary, then finally you can test your structural model, which takes like 5 minutes. And then you're like, oh, poop. You know, it failed. Yes.
In the continuum that we're in, how many times do we test hypotheses?
So far, we haven't tested any hypotheses.
You wouldn't do it in a hypothesized model? It's redundant.
I don't think I understand the question then.
Well, you've got your initial model.
Yes.
That you're going to be doing descriptive statistics, and you're going to run the EFA and the CFA.
Right.
Do we make any suppositions at the point when we first start?
Oh, do we create a theory prior to doing all this EFA, CFA stuff? Definitely. You always theorize before you even collect data. And before you even build your survey, you theorize.
Okay, so that's one set of hypotheses.
Yeah.
Then you're in CFA,
Mm-hmm.
and there's going to be changes to the model, obviously.
Yeah.
You create another set of hypotheses.
Okay, this comes to an interesting question, which we'll talk more about probably tomorrow or Saturday or whenever we get to the structural model stuff. But you theorize one thing, right? And then all your measurement model stuff figures out that one construct is no good, another construct is actually two constructs. And so what happens to your theory? You have to adjust a little bit. But you should always theorize a priori before you collect any data. The purist will say you theorize, you test, you report. There's no adjustment to be made. You report on what you found. And I often like to just do it that way. If there's enough interesting stuff. What if you theorize, you test, and nothing you tested worked? Well, there are two options. One guy I know, actually at Case Western Reserve University, defended his dissertation with 0 supported hypotheses because they were all very interesting failures. And so he defended it, and it was great. He even published parts of it with 0 supported hypotheses. Yeah, yeah. You have to be really good at wordsmithing. Yeah, very eloquent in your writing. And it has to be a very convincing story, very compelling story. But more often the case is you re-theorize. You don't just fish around and see what works. You re-theorize, find why is it the data happened to work out the way it did, and then theorize around that and create a story. You're not seeking 100% supported hypotheses. You're seeking an interesting story that contributes to knowledge and to practice, whatever that story may be. But again, the purist will say, don't change a thing.
So your answer is, once you have a set of hypotheses, that's what you should work with throughout.
Yes, you start with a set of hypotheses, try to work through those the whole way through.
And that's fine.
Yes. Okay. Yeah? By the way, none of this is related to CFA. Go ahead.
So in CFA, actually in CFA.
Yes.
I'm a little confused at what point do I introduce controls including that I intend to not make useful. In other words, controls are there.
Yeah, but they're just there. When do you include controls?
When do I in a measurement model versus a structural model?
Okay, good question. If controls are latent, I would include them all the way through. If controls are not latent, they're just one item. Just throw. If they're categorical, that's a different story. But if they're just single items like age or education, then you'd stick them in just in the structural model when you're testing your hypotheses.
Excuse me, age is categorical, isn't it? Age is...
No, because as you increase in the value of the construct, you increase in the trait of the construct. Yeah. So if I answered high on an age scale, I'm actually kind of old. Yeah. Same with education. I have little education and lots of education. As you increase on the scale, the value of the trait increases.
So categorical is...
Industry. This is worth talking about really quick. You can't include categorical variables in a structural in a causal model or in any of this stuff that we've done because they don't vary in a normal way. As you increase in, let's talk about industry. Let's say a value of 1 is marketing or service, a value of 2 is retail, a value of 3 is manufacturing. If I have a value of 3, do I have more industry than the service folks? That doesn't make any sense at all. And so an increase or a movement in that scale doesn't relate to a movement in the trait. You can't just throw those in like that. Yes?
Let's go back to the hypothesis.
Okay.
For the controls, if you include them in your statement, you should only do them for the latent ones and leave the categorical ones? Or you mentioned
You can include categorical controls. There's a way to do it through dummy variables. That is the technical term, dummy variables. And we'll talk about that hopefully on Saturday.
But do you hypothesize for all of them?
All the different categories?
Yeah.
If it's a control, you don't hypothesize at all.
You should mention them all.
You mention in the beginning, I'm controlling for this stuff. Now let's hypothesize. Yeah. Okay. Anything else before we talk about CFA? This has been informative. Good. Okay. So, we do a ton of stuff in CFA. Tons. The CFA, we go from, oh, that's right, they can't see unless I do this. Okay. The CFA, we go from the pattern matrix to a visual representation of that pattern matrix with constraints. In the EFA, we have 0 constraints. We're just letting things flow freely and see how they cluster. In the CFA, we say, no. These guys belong to this factor. And these ones belong to this factor. I'm constraining it based on my measurement theory. And I have a cool tool that does this for you, because building it by hand is just terrible. Let's just do it. Excellent. Yes?
I've said this before, but constraining means that those atypical 4s through atypical 1 actually, we're telling the model that it can't be anywhere else.
It doesn't belong anywhere else.
Okay.
Yeah. We still account to some extent for the correlation between these items and these items by including a covariance arrow here. But we're saying, no, you belong here. Okay. Let's do it. There's a lot to do. It'll be fun. If I can actually get out of this. Escape these. There we go. Alright, and then duplicate screen. Who here has Amos running? That was me. Alright. Okay. Of those of who doesn't have it running but will have it running tomorrow? A few of you? Oh, several of you. Oh, okay. So that's quite, how far should we go? Because if you want to follow along, you only be able to follow along up here. Darn.
Looks like it installed like Amos graphics, just Amos graphics.
Amos graphics, that's the one. Here's what we'll do. We're going to get going, and then you have the video to catch up if you need. Sorry, but the majority wins. Okay. So, we do this. We open up Amos, wherever that is. If you're in a Windows machine, which all of you are, because it only runs in Windows, you'd click on Start and just type Amos, and it's Amos Graphics. And whatever you last worked on will pop up. Whose model is this? Oh, that's Tim's. Okay, I'm going to just create a new. Okay, and I'm going to load my data. You can click on this little data thing. The interface is just rotten, just terrible. Or you can go to File, Data Files, which is so not intuitive. You'd think you'd go to Open, right? No. Go to Data Files. File, Data Files. And go find the data we've been working on. But before you do that, you should probably save that data, or else you won't get the most recent version.
You have the plugin already. Clean one, right?
Yeah, I have the plugin already. So if you don't have the plugin, let me walk you through that. If I can remember. I might have to watch my video to remember.
It's that step we can remember that, but then there's a link. What's it called?
That's right.
This is Amos.
Okay.
That's the deal of the matrix.
Okay, here we go. This is saved. Excellent. I'm going to include my data, file, data files, go find that data by double-clicking group number 1, and go to, oh, not Google Drive, Dropbox. Wherever you put yours, don't use mine. Data, bootcamp, and OK. And it says you have 377 sample size. Good. OK. So nothing happens, which is exactly what we want to happen. But my data is in there. How do I know my data is in there? I can click on this little white stacky thing, and I can see all the variables in my data set right here. So I know the data loaded by clicking on the white stacky thing, not the blue stacky thing, the white one. Okay. How many of you need the pattern matrix model builder in the plugins menu? A few of you? Yeah, none of you should have it unless you've put it in there yourself. Okay. This will be immensely helpful if it works. This is a plugin one of my research assistants built. Let's do this. How do we do it? It's on StatWiki somewhere. I have a YouTube video that is there a link on the wiki?
Yeah.
Oh, okay, let's go there. Okay. Here we go. StatWiki. It's probably in
At the bottom. Amos, EFA, CFA plugin right there, and resources.
Down.
Resources.
Down. Up.
Oh, here, right here, on the sidebar. I'm glad you guys know my wiki. You probably know it better than I do. So here's what you do. You don't click on it. You go right click, save link as. This is on statwiki.colabcreations.com. Or you can go, yeah, that place. And go right click that link, the Amos EFA CFA plugin on the left panel. Save link as. And do this for now. Save it to your desktop because we're going to have to strip it real quick. So save to the desktop. Don't click on it down there. Just go to your desktop. Am I going too fast? I can wait. Nice. Okay. Once it's on your desktop, you need to right click it. And I have a video for this. If you fall behind, there's a video for how to do this. There's a video for everything we're doing. Go to Properties and go to the Security here. On the General tab, there's this file came from another computer. It might be blocked. You want to unblock it. So I clicked on Unblock. And then hit OK. That's in the General tab when you right-click and go to Properties. And hit OK. And then, again, am I going too fast? Good. Or you're shy or something. Then you need to go find Amos, which is the hard part. I'm going to open up my computer. Go to, wow, I need more space. Yikes. Oh, that's because I'm recording these huge videos. Yikes, I'll have to get rid of some of them. Okay. In fact, that might run out of space. All right. So you'd open up my computer, go to Program Files or Program Files x86. If you have that one, it's in x86 if you have that one. If not, it's just in Program Files. IBM, I think, or is it? Yeah, I think it's IBM, SPSS. And you can see my trail up here at the top if you're falling behind. Amos, not Amos 21 for some reason. Amos 21 if you have 21, 22 if you have 22. Whatever your most recent number is here, the highest number. Plugins, and so here's the trail right here. Program Files, IBM, SPSS, Amos 21, plugins, and you'd stick it in here. You just drag it and drop it inside of this plugins folder. I already have it in there, so I'm not going to drag it in. What this does is creates a new plugin for you, a new program that will run on your Amos software, which is awesome. Saves so much time.
Jake, we can find this where?
On my StatWiki, let's see, StatWiki, right here on the left column, and there's a video that shows you how to do all this and how to install it. So once you do that, if you close Amos and reopen it, it'll show up in this plugins menu as Pattern Matrix Model Builder. Did anyone successfully get it in there? Yay! All right.
What was the step in between putting it in, dropping it in that folder and loading it in?
I just close it and reopen it. Yeah. I'm so excited that worked. Now let's see if it actually works. Okay. Anyone still having trouble? Because we have some really clever students who can come around and help you out. No? Oh, yeah, over here, yes? Trouble. Okay. I'm one of those clever students.
Yeah, just a sec.
And then close and reopen Amos. Okay, once you reopen Amos, make sure you add that data back in. Did you close Amos and reopen it? Yeah, it's not there, so I mean, you had like early, like a month ago or two.
Carry on the Windows side. And so I can the folder.
Anyone else having trouble? I can send pictures. No?
Sure you have the right one.
Yeah, they're together. That's only because one is tab. Tab is space, space, space. It'll work. Trust me.
I just looked up the overlaps.
You close it, you just reopen it, and it's not showing. Then you put it in the plugins. do you have multiple versions of Amos on your computer? When you open up the SPSS Amos, where there are 20, 21, 22.
Did you allow it from your desktop, or did you try to?
Yeah, did you drag it straight into that folder, or did you go to the desktop version and unlock it? And then put it in. Oh, okay, I'm not sure why it's in there till now. Okay, moving forward. So here's what you do. You go get that pattern matrix, the final pattern matrix we built. We might have to recreate it. I'm going to just recreate it real quick for those of you who didn't have it. Let me figure out what it was. Factor analysis. It was this. We had info acquisition 1 through 5. So everything from info acquisition. Decision quality, we dropped 6 and 8 and 1. 168. In fact, 168 was the only thing we dropped from this whole pattern matrix. So run that again. I'm going to go ahead and suppress those small values, 0.3. Continue. I'm going to uncheck sort by size. That way they're in the proper order. And then hit OK. And then go to the pattern matrix. And here's what it looks like. And that's fine. I didn't sort by size. That's why it's sort of all over the place.
Yeah, within a given factor.
Right. And then I'm going to right-click, copy, wait for it, there we go. Go over to Amos. If the data is currently loaded, which it is, hit Plugins, Pattern Matrix Model Builder, and just paste it in there with Control-V, and create diagram. Please work. I've never had it not work.
It works beautiful.
Yay!
So for your research assistant that did this for you?
Yeah, Russ Taylor. You know his name.
What sum of money for food, ongoing food is he? This saves so much time.
It's great, isn't it? I was paying him, don't worry. Yeah, all right.
Market it to IBM.
I've called IBM, and they said, sorry, we don't deal with third parties. Yeah.
In terms of constraints, either the latent factor in one of the patterns.
Yeah, this is one of the latent factors from the pattern matrix. Each one.
Could you change that?
The names?
Yeah.
Yeah, I will. Yeah. Okay, one thing before...
Sorry, you did, there are a couple of the, in factor analysis, you said take out sorted by size, but that was only
Yeah, and then I added the suppress, I changed it to 0.3. Yeah. For those of you who have never had to do anything different than use this plugin, lucky you. For those of you who have had to build these without the plugin, it's a pain in the rear. Like really, this would have taken solid 20 minutes, and then you might have made a mistake.
And
Yeah.
maybe it would run, maybe it wouldn't.
Exactly. Yeah, but this will always run. Yes.
Could you go over just again how you copy the path matrix?
Yeah. So from the over here, you just right-click it, and then copy. Yeah. And then over here in plugins, go to Pattern Matrix Model Builder, and then just.
Is that plugin specific to a version of? I mean, I bet it was 19 on here. It's not.
It's not working with the 19. It's based on your .NET framework. If you have the most recent .NET framework, which is a Microsoft thingy, if you've been updating your Windows regularly, then you should. Does it? Yeah, that would be the issue.
Give me an error when I copy it into when I open up it, when I reopen this.
Oh. Yeah, I'm not sure. I have to troubleshoot that individually. Okay. Okay, before I forget, I need to go delete something from here, or else I'm going to run out of room on my computer. Delete this one, select, go here, and delete this one. Yes. It's already on YouTube, so that's fine. Good. Recordings. Okay. Here we go. Back to Amos. I'm going to rename each of these by double-clicking them. This one is usefulness. So useful is what I'll call it. This one's joy. Sorry, it's so small, just because there's so many. This one's playful.
Yeah, but you can click on them all and then
You can, yeah. This one is atypical use. A word on format, you can't have spaces in these names or else it gives you errors later. So no spaces or mathematical symbols in these. Number 5 is decision quality. 6 is comprehensive use, comp use. And 7 is info acquisition. If you want to zoom in, it's just scroll in, scroll out. Okay. This will actually just run after we save it. So let me go save it somewhere. Again, please don't save inside the Dropbox. I will. So you have, so I'm going to save everything in Dropbox so you have it after this workshop to play with and to refer to. Bum, 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 bum. Data, Amos. Here we go. None of this should be in here. I'll just write over it, CFA initial. Yes. Okay.
You can also change the headings in the pattern matrix grid before you copy, and then we'll drop those in.
I bet that's the error. I bet when you're throwing it in there, in your pattern matrix, do you have the name of the variable or the label?
It's not the I don't even get that far. The plugin doesn't load.
I'll have to figure that out. Okay. Here we are. So I saved it. I'm going to change some properties real quick. If you go to this colored abacus thingy, which makes no sense, or go to analyze somewhere in here, something, I don't even know where it is in there. Click on this colored abacus. It pops up this little dialog box. We're using maximum likelihood as our algorithm. In my output, I want standardized estimates and modification indices for now, with a threshold of 10 right here. If that doesn't make any sense, don't worry, we'll talk about it. Okay. And close it. There's no OK button. You just have to close it. And save and run. Run is this not colored abacus. I thought it was a piano at first, but piano black keys only come down. Okay, run. Ooh, variable decision quality 2 is represented by a rectangle in the path diagram, but is not an observed variable. Seriously? Decision quality 2. Let me go look in here. Is there no dec qual 2? Holy cow, where's decision quality? Has somebody been messing with the data? It doesn't work, it doesn't exist anymore. Oh, it's system satisfaction. All right, that's right, I saved this elsewhere. Wrong data set. Ha. Okay, phew. Desktop. I stuck it in here. Phew. Data, this one. Oh, that scared me. Okay. Now let's run it.
Maybe it was the one on the desktop.
Desktop. SEM BootCamp. Oh, this one. Open. Yeah, 375. Okay. Okay. Now run. Find the right data. That's important. And it ran. Now nothing happens, which is so Amos. What you got to do is click this up button. So not intuitive. And then it's still funky, so you got to click the standardized estimates right here. And now, here we are. Let's go ahead and eyeball this real quick. Zooming in slowly, slowly. Okay. Just eyeballing this, we want the average loadings, standardized loadings, to be above 0.7, which we've got right here, and here, and here's pretty good. We have a couple low ones, but I don't think it's averaging out low. This one's great. This one's great. Now, we were worried about decision quality. Look at that. That's fantastic. Like I said, it sort of inflates things a bit when you get into Amos. And even information acquisition, we're pretty good. Info acquisition 5 is a little low, 0.59, but the rest are pretty high. We might end up deleting info acquisition 5. We'll see.
I'm sorry, tell us how you got all those loadings to show up.
Yes. I ran it with the color or the not colored abacus thingy. And then you press the up arrow. And then you press standardized. Did that work?
It didn't like some of my variables, but
Nice.
I'll come back to it.
Yeah, you have the wrong data set probably.
Yeah.
Or you didn't save that data set. Okay. Yes.
If I may ask, in terms of constraining the model, why, first let me ask you, where did you constrain it, the path or the latent variable?
I constrained the latent variable. Let me.
Why?
Why? Because that's the default. I just didn't change it. Should we constrain the latent variable instead? What does Tony say?
Yes.
Let's do it. Okay, if you didn't understand that conversation, don't worry about it. I'm going to click the down arrow. Notice that I have constrained to 1. By default, Amos does this. It constrains the latent one of the paths on the for each factor to 1. According to an expert, we should instead constrain the variance on the latent variable to 1. How do you do that? Double-click this arrow. On parameter, change this to nothing, and add a 1 here. 1, 1, 1. Delete. Delete. Did she have a reason for that you recall?
No, I think that's what I'm struggling. Either I missed it. And,
It allows for unfair weighting, unfair weights on an unstandardized loading. But on a standardized loading, it should have no effect. Yeah. But also, if you were going to run an invariance test, you couldn't check if that path was invariant.
Right, I see.
Yeah. So that would be a benefit.
The primary reason is for probably not the variance, I think.
Okay. Okay. So might as well just keep it this way the whole time.
Yeah.
All right. 1, 1, 1. Delete. 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 There we go. Yeah, if you double click and it's in the parameters, you want to change the regression weight on those constrained ones to nothing and add a constraint to each of these factors. So I should change the model builder so it does that by default. Okay. I just have to go into the code, figure it out. Bah. Okay, let's see if it still runs. Yay, it still runs. And there we go. Still runs, and it runs just fine. Identical loadings for standardized, not for unstandardized.
Right.
Yeah. Okay. So is this good? Yes, it is actually. It's very good. And can we find out how good? Convergent validity, discriminant validity, things like that. Let's do that. I actually have another plugin which I haven't distributed or made a video about.
Oh, you tease us.
Yeah. I showed some of you this already. It's called Validity Master. Let's see if it works. I don't think it worked. Nope, it didn't work. Never mind. Okay, ignore that. I have a stats tools package. If you go to the Dropbox, and remember, don't go to the Dropbox. Get your own copy.
Is that different from the validity master we have in the...
No, it just works in a browser instead of in Excel, for those who had trouble with the Excel version. So here's the stats tools package. I'm going to open it up. It works in Excel. I have something called the Validity Master. It's the first tab down here, first sheet. And there are lots of rules, which is also why I made this plugin, because it doesn't have any rules, which is great. But it needs some tables. What we're doing, sorry, let me give you some preface. We want to see if there is convergent discriminant validity and reliability in this model. And this is how we do it. You look at the loadings here, you look at the covariances here, you compare them. It's a whole ton of work and a lot of equations, a lot of math. And so I created a macro in Excel that would do it all for us and format it and identify problems and tell you what they are and highlight them, which is nice. So if you go to the output, which is this little view text thingy, the one under the colored abacus next to the save, and you go grab whatever it tells us to grab. It says grab the correlations table and put it in A1. So estimates, scalars, correlations, that's where it's hidden. Estimates, scalars, correlations. You have to left click somewhere outside of it. Again, not very intuitive. Left click out here somewhere and then right click and hit copy.
I'm sorry, my correlations, right?
Yeah, correlations.
Oh, mine doesn't look like that.
That's probably because you didn't use standardized effects. So you have to go back to the colored abacus thingy and check for standardized. I'm going to paste those in there, and then you have to rerun it also. Paste those in there just like that, and then it wants the standardized regression weights in F1. So I'm going to go grab those standardized regression weights, right click, copy, left click first, then right click. If you left click out here on one of these links, it'll give you a bunch of information, so don't do that. And paste it in here, and then click the button, assuming you don't have all these problems here. Yay! And it just creates this for you, which is great. And it says, hey, you do have some problems, actually. 2 discriminant validity issues with information acquisition. Darn. And we knew we did, right? From the EFA, we knew we had some discriminant validity issues with info acquisition, with decision quality. Because the square root of the AVE, which is on the diagonal.
I'm sorry, James, I did check it, and it gets me something that looks a lot skinnier than.
Okay, we'll resolve that real quick.
Correlation.
Yeah. Oh, yeah, it's because you didn't rename your factors. You'll need to rename your factors so they're not 1 and 2. They're like usefulness or joy, whatever they were.
It's right here, like this.
You put that in the label area. Don't forget.
You get this to them.
Text. Oh, press them down. And now, so you name the label and just get variable still. Variable. You're welcome. Okay. So what this is telling us is that we have discriminant validity issues that we expected, which is a problem. Info acquisition is too similar to decision quality. This value here, this 0.738, this is the correlation between info acquisition and decision quality. If we go back to Amos and we look at information acquisition and decision quality, look, it's 0.74 is this correlation value. That's really high. We go back here, yeah, 0.74 or 0.738 if you have more decimals. And that's greater than the square root of the AVE. The AVE is the average variance extracted. The AVE for info acquisition is 0.5. If you square that, or a square root of that, you get this number here, which according to people, literature, Fornell and Larker, 1981, it has to be greater than the correlation. So that's a problem. How do we fix that? Any guesses? How do we fix that? It's great everywhere else. Like it's CR. Let me show you. It's CR right here. Composite reliability, sort of like Cronbach's alpha, but more reliable, is 0.84. It needs to be above 0.7. That's fantastic. Its AVE is above 0.5. I mean, it is convergent. It is a good factor. It's just not discriminant. It's shared variance, maximum shared variance, MSV, with the AVE, or is greater than the AVE. So it shares more variance with decision quality than it shares with itself. That's a problem.
You could look at maybe the correlations among the items of decision quality and info.
Yes.
And drop them.
What we want to do right now is increase discriminants or increase convergence. Because by increasing convergence, we're distancing ourselves up a little bit. I think my first approach would be to just lop off information acquisition 5. It's the low one. It's keeping our AVE down. If we could increase our AVE, then we're increasing the square root of the AVE, which is good. So let me go ahead and lop it off. This little X thingy is how you delete stuff. And you don't double click, you single click. You don't drag, you just single click. I'm going to single click information acquisition while I have the X thingy on. And get rid of its error. And run it again. Hit the up arrow. Hey, these values all look fantastic, 0.75-ish. So now I'm just going to rerun it. Go back to the Stats Tools package, hit click reset. And now we're back to where we were. I just reset everything. And run that table again. Go grab the correlations, I think it was. Correlations, left click, right click, copy. An analysis like this used to take eternity. And if you had to change something, you had to do it again. Oh, can't even imagine. Actually, I can because I had to do it. That's why I wrote this. Save myself time.
What is the criteria to constrain the path when the SPP is, what was we looking at, the correlation table, sample regression rate, to trim it?
We trimmed information acquisition 5 because it was bringing down the AVE, the average variance extracted, because it's based on those loadings. And those loadings, they were all 0.7 except number 5. It was like a 0.59. So it was really bringing it down. So when you have low convergence, low AVE, then correlations with other factors are more impactful. So if we can increase the AVE by increasing the average loading here, then our distance, or the extent to which other factors can affect us is lessened.
Oh, you suppressed utility acquisition 5.
Yeah.
And again, why did you pick up 5?
Because it had the lowest loading by a long shot. Everything was sort of the same 0.7s, and then there was this 0.5, which is very different. Yeah.
So
I
is it
didn't have
then?
that one there.
So is it then that since the convergent validity is like higher than the correlation, because the correlation's still 0.7?
Yeah, the correlation doesn't change much, but our AVE is higher because our convergence is stronger, and so that it's distancing itself just by being stronger.
Okay, so in that way of having that much more convergent validity, it kind of overrides.
Yes, overrides the discriminant issue. Okay. Okay, that was a lot to take in. But the end story is if we get rid of info acquisition 5, we're cool. We have a valid model, wahoo. There are no validity concerns. And I just copy this table and paste it right in my paper. And make sure you mention that the square root of the AVE is on the diagonal. And you might get rid of these 2 columns because nobody knows what those are anyway. But they are actually very useful, but nobody ever uses them. This is the maximum shared squared variance. So essentially, which one of these values on the diagonal is the highest when you square it. And the average shared squared variance is when you take all these values on the diagonal and average them, or square them and then average them, what is that average shared variance? Nobody uses them for some reason, but they're actually very useful for determining discriminants.
Could you show again where you compare the square roots again to?
Yeah, the square root of the AVE is on the diagonal, and you want this value to be greater than any correlation with another variable. So anything to the left of it or below it in this little matrix here. Yeah. So for this one right here, we want it to be greater than this value and greater than these values right here. Any correlation with another factor.
If you have a validity concern, how far would you go?
Okay.
In terms of,
yeah. Sometimes you won't be able to resolve validity concerns. In fact, I think in that paper I told you not to republish, I had a concern. Don't hear me. Let's see. Let's see if I ended up fixing everything. Here it is. No, I didn't. Ha! Active problem solving didn't pass the convergent validity test, and I left it in. And so, but oh, this is so interesting. Okay, it didn't have a high enough AVE. The AVE is supposed to be 0.5 or higher, and it didn't. What I said was, right here, and I think this is worth reading. To establish convergent validity, the AVEs should be greater than 0.5 according to this person. We meet this threshold for all factors except active problem solving, which is right on the border at 0.445. It's actually not right on the border, but I make it sound like it is. Although this is below the recommended threshold, we opted to retain it because it met criteria for discriminant validity and reliability, which it did. And then I just move on. Now, but watch. Active problem solving, I call it active cope in the model. Look, not significant. Because it's not convergent. It goes back to this problem Bill was talking about, right? If you don't have consistent movement, convergence, how are you going to predict anything if you're not consistent? And so we never find a significant effect out of active problem solving. So it comes back to bite us in the bum. Yeah.
So if you...
Yes, Nadia?
I'm having a problem with the P close.
Yeah, we'll get to model fit tomorrow for sure. Yeah. Yeah.
If you go ahead and say eliminate some items, some factors, would you resort back to the CFA from the start? Or?
Yeah, you're gonna have to restart that CFA. You might even restart the EFA if you're totally exploratory. If you don't have a solid theory that you're building off of, you might just start back fresh. Ooh. Yeah. Okay. All right. I think I'm just going to answer questions for the next few minutes and then call it quits for today. Any other questions? Oh, really? Okay.
Could you send us the data set I used didn't have any problems, so I couldn't practice solving. Could you post that data set, or is it the same one?
It's the same data set. Yeah. I should probably use a more problematic one. But we have talked through mitigation.
At what point do we look at modification indices to see if there's anything to predict?
During model fit. We'll take a look at that tomorrow.
Okay, so
yeah, it's a larger discussion, I think, than 10 minutes. Anything else? Yes.
A couple of us, when we try to run the model, are getting system argument exception, the path is not a legal form.
Yes, what you do is close Amos, save, close Amos, and reopen it. And hopefully that'll work. Amos has weird errors sometimes that are fixed when you just restart it. Anything else? I hope you go hiking or skydiving or something. It's fun. It's beautiful out here. All right. I'll post this to YouTube as soon as I get home. I'll just start uploading. And the first one from this morning is already uploaded. I get claps? Ha! That's right. Oh, that's right. We're in a business school. You have to clap. Ha! Uh-oh. Record. Wait. Has it not been recording? No, I know I hit record. I've been recording. Hide. Wait. Scripts, recordings. Come on, where is it? It's been recording. When I hit delete, did it stop recording?
Do it all over again.
No, you gotta be kidding me.
You go ahead and do it. Yeah, we'll come back.
No questions, it'll go faster.
Undo it.
Undo it. That's not gonna.
That's the morning.
Yeah, that one's there. But I was recording when I clicked undo, or when I clicked delete. Oh my goodness! All right, well, luckily I recorded last year's boot camp. It's online. I'm so sorry about that. Wow. Just clicking on this made it stop recording, and it didn't warn me. I think.